Yes, so my name is Kevin. I'm another educator here at Zoo Atlanta. And first off, I would like to wish everyone a happy STEM day. But I am here in Scaly Slimy Spectacular, which is where we house most of the reptiles here at Zoo Atlanta. And I have a very cool one to share with you guys. So let's take a look. All right, so I am here with our Gaboon Vipers. So these are a very cool and very unique species of snake that we have here at Zoo Atlanta. They are native to Western Africa, and they have some really interesting things about them that set them apart from a lot of other snakes in the whole world, and also just the ones that live here. So first off, I do want to mention these are venomous snakes. So they do have a pretty strong form of venom, and that is injected into their prey through fangs. But something that sets these snakes apart from a lot of other ones is that these snakes actually have the longest fangs of any venomous snakes in the whole world. So they're about 2.5 inches long, which is about as long as your finger. And that is going to be really, really large for the fangs on a venomous snake. Most of them aren't nearly that big, but they actually function kind of similar to a needle, like when you're getting a shot at the doctor's office. Their venom is stored in their venom glands, which, if we can take a look down a little bit, that is going to be on the sides of her head here, on the left and right side. And that's what's going to give them that kind of diamond-shaped, triangular-shaped head. That's going to be something that is common to most venomous snakes because their venom glands are stored on the sides of their head. It's going to give them a triangular shape to their heads. That's one way that you can generally identify a venomous snake, but it's also something that non-venomous snakes have developed the ability to mimic. So things like king snakes will often kind of flatten out the sides of their neck in order to look a little bit more like that. But these guys have very large heads because they have big venom glands, and they inject that venom through their fangs into anything that they're trying to prey on. And that's going to mostly consist of small animals, things like rabbits or mice, but they are actually able to eat some really big kinds of animals. So this is a fairly large snake. They're not particularly long, maybe about 3 feet, but he's very, very wide. There's a lot more than most other snakes you're going to see. And so these Gaboon Vipers have actually been known to eat things as big as antelopes, which is pretty crazy. I'm not sure how they would manage to get it. It would mostly be smaller antelopes, like the calves of them, but they still have been known to eat them, which is pretty wild. They eat prey whole. Snakes actually don't really have teeth that they can chew with. They just have their fangs. And so they have a way that they can kind of detach the middle of their jawbone to stretch their mouth around their prey, and they will actually swallow it whole. And so you can generally see when a snake has recently fed, because they'll have a big lump in the middle of them while they're still digesting their food. It takes a long time since they don't chew it up into more easily digestible pieces. But these guys are ambush hunters. So that means that they are generally going to be kind of waiting along where they expect some sort of animal they want to feed on to come. So as you can see, she blends in really, really well with the leaves around the habitat. They live in pretty dry regions in Africa. And so she has this very cool kind of diamond pattern along her body that is going to help to blend in with the leaves here. So it's going to be really hard to spot one of these snakes, especially if you're an animal that doesn't have the greatest eyesight. And so they're going to be able to blend in really well and not be seen while they wait for something to come along. And now these snakes don't really have the best eyesight either. but they do have something that gives them the ability to spot their prey really, really easily. So if we can get a little bit closer, all right. And we can see right next to their eye, they actually have this little hole that's right near the tip of their nose. That's something called a pit organ. And so that is a very special organ that is common to a few species of venomous snakes called pit vipers. And that basically gives them heat vision, which is really, really cool. It allows them to see the thermal energy being given off by anything that they would want to prey on. And so instead of trying to look for, say, a brown rabbit against this brown background of leaves, they would be looking for the red and orange hot signature given off by the rabbit compared to the cooler blues and greens from the environment. It gives them a really easy way to spot prey against things that wouldn't otherwise be giving off that heat. And so it makes up for the fact that they don't have the greatest eyesight, and they also can't hear. So snakes don't have eardrums like we do. They actually can detect vibrations in the ground throughout their body, but they aren't able to hear like we are. So having these special pit organs is a great way that they make up for that. And I wanted to talk a little bit more about how snakes at Zoo Atlanta have kind of impacted research into bio-inspired design. It's really, really cool. These guys have a very unique way of moving. So since they're so wide, they actually they can't really slither along the ground like most snakes. They actually inch along a little bit more like how a caterpillar would. And there's some other snakes we have, like sidewinder rattlesnakes, that have some very unique forms of movement. And researchers from Georgia Tech have actually come to Zoo Atlanta to study our snakes because they've been working on building robots actually to travel throughout the desert. And they've been studying the ways that snakes move efficiently over the sand. And so it's really, really cool. It's been able to teach them ways to make robots more efficient and to improve the design of this technology that they're working on. And I always think that's really, really awesome in that we can take inspiration from nature and kind of use it towards creating new things. But these are one of my favorite animals in the whole world, my favorite snakes we have here, and I think they're really cool. But I would love to hear if you guys have any questions about our Gaboon Vipers or just snakes in general.
Oh, we have got an influx of questions. Let's go.
All right.
We want to know, let's see, we'll start with, why do they have rattles?
Why do they have rattles? Well, rattlesnakes are going to have rattles because it's going to be the best way that they can warn things that they are not to be messed with. So just like these Gaboon Vipers, rattlesnakes are venomous snakes. And so they are going to have a way to defend themselves by biting and using their venom, but they don't really want to have to do that. So instead, they will use their rattle to make that really distinct noise. And it's going to serve as like a natural deterrent for anything getting too close. So if you ever hear a rattle when you're outside in the woods or anything, what you need to do, you just make sure to stop, kind of back away slowly from where you are and give them plenty of space. You're probably going to hear them before you see them, but they are really not aggressive animals. They just want to be left alone. And so they use those rattles as a way to tell other animals to stay away and let them be.
All right. We also want to know, how long does a Gaboon Viper get? And also, what is the longest snake in the world?
So Gaboon Vipers are not particularly long snakes. This is her whole body right here. We can take a look. But they are pretty wide. This one is about 3 feet. They're not going to get a whole lot longer than that, probably up to maybe 4 or 5 feet total. The males do get a little bit larger, I believe, but they are not really that long. They are very heavy, though. The longest snake in the world, however, is the green anaconda, We actually have one of those here at Zoo Atlanta as well. And they can get about 35 feet, I believe. So much, much, much longer.
Okay. We want to know a little bit more about venomous snakes now. How many venomous snakes does the zoo have, and why do we care about venomous snakes?
So we have a big variety of venomous snakes. So we have these guys, the Gaboon Vipers. We have a few types of rattlesnakes. We have a Cape Cobra. We have a pretty good variety of venomous snakes, and they are a really special kind of snake. And we care about them because they're ones that are not only really important to their ecosystem, but they also tend to get a very bad reputation. People think they're scary, and they actually kind of end up getting killed a lot. It is legal in the state of Georgia to kill venomous snakes because they can be threatening. But for the most part, they really don't ever want to mess with people or anything. They're not aggressive. And so I like to talk about venomous snakes really because people tend to have a lot of ideas about them that really aren't necessarily true. They are going to want to be just kind of going about their lives just like any other snake, whereas non-venomous snakes mostly kill by constricting. These guys are just going to be using their venom to hunt prey instead. But they have gotten a pretty bad reputation because of that. But I like to talk about them because I don't think they really deserve it.
I agree with that. We've got a question in here that says, aren't snakes more scared of us than us to them because of how big and scary we are?
Yes, that is definitely a good question, a good point. Yeah, we are going to be a whole lot bigger than these snakes. They are definitely going to be a little scared of us. They're going to feel threatened. And that's why if you're ever out in the wild near, say, a rattlesnake, they're generally going to rattle and try and tell you to back off. It's because they feel like, something much, much bigger than them is walking up on them, and they just want to be left alone. And so they are going to be scared of us, and probably a lot more scared of us than we need to be of them. As long as we give them plenty of space, we don't really need to be afraid of these kinds of snakes, and we can allow them to kind of go about their lives just as any other snake would.
All right, we're going to take one last question and then move on because we have more animals to see. And this is, could this snake eat a kid, or how large of an animal can it eat?
Could it eat a kid? Well, that's a tough question. Probably, definitely not anyone older than like a toddler. They technically have been known to eat animals as large as baby antelopes, but they are really not going to be ever wanting it to hunt a person. So they aren't the largest snakes in the world. Mostly they're going to be wanting to feed on things much, much smaller than people, things like a rabbit. And that's going to make up the majority of their diet. They're really not going to be wanting to try and eat a kid.
Awesome. Thank you, Kevin, so much. We're going to come on back over to me so that we can see some more animals. Again, I know there's a bunch of questions that have still popped up in our question and answer. I will answer this one last one as we jump over to Liv in a moment. But what do they do for our environment? Why do we care about snakes and venomous snakes and things like that? They help keep rodent populations under control, which in turn stops a lot of diseases. So we do want to keep having snakes around. So even if you may not think they're the coolest animal ever, which I think they are, it's important to realize that they are important to their environment. They're helping kill off a lot of rodents that would take over. And they're also going to be food for a lot of other animals. They're really important to their environment and to their ecosystem. Okay, let's move on from snakes. We're going to go visit Miss Liv again. She has moved to a different animal. Let's see where she's at.
Hi guys, I have moved around, so I'm going to flip my screen around so we can check out one of the coolest gorilla animals. I just spoiled it. It is our gorillas, Western Lowland gorillas. All right, let me try to get to my screen. 1 second. You can hear me. Okay, so there's quite a lot of things to see in this shot. Hopefully we can see what I can see. We have a couple different families of gorillas here at Zoo Atlanta, and this is just one of them. There are several members of this family, including our 2-year-old, will be 3-year-old this July, baby Floyd. So I guess I can't say baby anymore. He's like a big toddler, and he is up on the top of that tree. And there are several other ones. I'm going to try to move around a little bit so we can kind of see a few of them. For some reason, I can't get my phone to zoom in on anything, which is awesome. So hopefully we can just kind of see our gorillas, kind of like you're on an African safari. They're not super close up, but they are there. So like I said, these are Western Lowland gorillas, and they have been here at Zoo Atlanta making our zoo famous for as long as people can remember that are from here. We have the famous Willie B. We had the famous Ivan. Some of you may have seen Ivan's movie or read Ivan's book. They were both here at Zoo Atlanta, and some of their children and great-grandchildren are still here with us because we have just several generations of gorillas with us. Now, gorillas are super smart, and they are definitely similar to us humans in a lot of ways. Sorry, I'm really trying to see. Oh, maybe this is it. I'm trying to see how I can zoom in. I'm so sorry. But you can hopefully kind of see Floyd playing in the little hammock there. There we go. So these guys are from Africa, and unlike humans, these guys cannot swim. They are not amazing climbers like the orangutans are. Orangutans are also here at Zoo Atlanta. They're super amazing climbers. They spend almost their entire life up off the ground in trees. And gorillas are quite the opposite. Obviously, you can see they are climbing. They can climb, but they are typically going to be on the ground more, especially those big adults. They weigh a lot. The babies, the toddlers, the teenagers, they're going to be the ones seen more in trees, and not so much for living purposes, but just for playing, for fun. You can see two of our little ones right there. They're just playing. They're having a great time. That big tree structure right in front of you is like a giant jungle gym, like a tree house to them. I don't know if any of you have tree houses, but I definitely had several growing up. And to me, that's exactly what this is for them. But yeah, typically in the wild and here at the zoo as well, they're going to build nests every single night out of things they find around where they live. Giant leaves, branches. Here at the zoo, we give them those type of things. We give them hay, and they're going to build these nests every single day. And it depends on where they go. They might go to a new location, depending on where's safe. It's all about where the silverback or the leader, there's a grown-up male that lives with each family of gorillas, and the rest of the gorillas are going to be mostly female. The exception are younger males. They will typically leave and form their own families once they get old enough. So if I see the silverback, he's really far away, and I don't know how to zoom for some reason. It's not working, but he's way back there. And they're really easy to tell apart, the silverbacks, because exactly how they sound, they do, in fact, have a silver back. The rest of them are going to be kind of just all black, a little bit of brown sometimes here and there on their chest or their head. When they get older, they do turn a little bit gray, just like us people. But yeah, like I said, they do build nests every single day, and we simulate that here at the zoo and allow them to build their daily nests. But those nests are going to be on the ground. They're not going to be up in trees. And that protection is all the silverback. The leader of the group is going to keep his ladies, his children, as safe as he possibly can. And if he needs to defend his group, he will. Gorillas are not fighters. They are very docile, chill animals. They don't want to get in fights. They don't want to hurt any other animals. If two silverbacks get in a fight, or a silverback tries to defend his group from a predator, they're going to try to do a lot of behaviors like showing off their teeth, beating their chest, charging. behaviors that aren't fighting necessarily, but showing how strong and big they are. They want to avoid fighting at all costs if they can. We got a few gorillas in our line of sight. Hopefully you can see some of them. These guys are herbivores, though. They're not going to eat any meat. They are plant eaters. They get fed a variety of fruits and veggies here at the zoo. They get fed things like apples and bananas and salads and hay, and they love anything and everything leafy and green and fruity. And that is the same in the wild. They're going to eat things like any fruits they find, flowers and seeds and twigs, maybe some insects here and there. But for the most part, they are plant eaters, herbivores. And that is basically my gorilla talk. If we have time for questions, I'd love to take some. Colleen, do we have time for questions?
We do, yes. We're only going to take a couple this time. We want to know, do they eat bananas? And aside from bananas, what might they eat?
I think they definitely do eat bananas. I'm sure they would love them. What else do they eat? I don't think there's a fruit that they don't eat. I've seen them here at the zoo. They've thrown them anything from apples to oranges to watermelon. Sometimes they'll give them like popsicles, like frozen fruit inside, like an icicle. So they have to get through the ice in order to get to the fruit. Just things to spice up their lives and make it more interesting. Over at Africa, they're going to eat anything green that they can find. And a lot of times that's why they move and travel to new locations. Africa basically has 2 seasons. It's a rainy season and a not rainy season. So during those months that it doesn't rain, it's going to be harder for these gorillas, these plant eaters, to find food. So the silverback gorilla is going to lead his troop, his family, to places maybe miles away from where they were previously in order to find anything green that they can possibly eat. And like I said, that does include all types of trees, all types of plants and seeds, flowers. And if they get really desperate during those not so rainy months, they will eat small insects or anything, maybe a small mammal if they have to, but that would be pretty rare. They'd have to be pretty hungry to not eat plants.
All right. We also have gotten in a couple times. Is a gorilla a type of monkey?
Gorillas are a little bit different than a monkey. They're considered what we call a primate. Best way to know if it's a primate or a monkey is going to have tail. And just like us humans, we don't have tails. So primates do not have any sort of tail. So primates, like a gorilla, like an orangutan, do not have a tail. So that is the main thing that differs them from a monkey.
All right, and we're gonna take one last question, and then we've got one more animal to share with you guys before we run out of our time today. And our last question is gonna be, how much does a gorilla weigh? How big does it get?
That's a good question. How much do gorillas weigh? The females are going to differ quite a lot. They're going to be around 200 pounds as the girls. Oh, look at that. Some chest beating. And the males can actually get up to 450 pounds. So quite a big difference in males and females. And we have baby Floyd, who's probably, I don't know, 20, 30 pounds, maybe. He's so small still. So yeah, females are about half the size of a full-grown silverback male gorilla.
All right, very cool. Thank you for sharing the gorillas with us. As I said, we have one more animal we want to share with you guys. So we're going to jump on back over to Kevin for our last animal before we run out of time. All right, Kevin, you there?
All right, yes. So I am back here with one more animal I want to share with you guys. Let's take a quick look. So I am here with Rinka. He is our Komodo Dragon here at Zoo Atlanta, and he is 11 years old, and he is another really cool reptile. I know we talked about snakes a little bit earlier. This guy is actually the world's largest species of lizard, and they are another one that has some very unique things about them. So These guys are the biggest kind of lizard in the world, kind of by a pretty large margin. They are a type of monitor lizard, but they're going to be much bigger than any other monitors. They can get about 10 feet long and over 250 pounds, which is pretty crazy. Very, very, very big. Rinka here is full grown, so he's 11 years old, but he's not nearly that big. He's about 7 feet and a little over 150, less than 200 pounds. So he is full grown. He's not going to get any bigger, but he is not as big as they get. They can definitely get even larger than Rinka here. We can see his head here. He's laying down behind some of these stumps, and you can see a little bit more. His body goes under here. But these are a really fascinating animal, just like the other ones we've seen. And they have some very unique things that set them up well to live where they do on the Komodo Islands in Malaysia. So that is the only place that you can find these kinds of lizards. They are not found anywhere else in the world, but they are the apex predators on the Komodo Islands, of course. And they have adapted to live there really, really well. So when they're first hatched, they're obviously much, much smaller than Rinka here. And so they are going to actually spend most of their time living in the trees for the first few years, because that's where it's going to be most safe for them. So they are going to be a whole lot smaller and subject to getting eaten, actually, by larger Komodo dragons. So the babies stay up in trees for a while and then kind of come down to spend most of their life on the ground after they get much bigger. But they are also actually good swimmers. So they live on the Komodo Islands, which is a chain of small individual islands in the Pacific Ocean. And they will actually swim from island to island to hunt down prey. They are going to be similar to the Gaboon Vipers in that they're going to be mostly ambush hunters. So ones that want to wait for something to come along rather than try and chase it down. But they are really fast in short bursts. So they can run about, I think, 12, 13 miles an hour in a short time frame. So they can definitely move pretty quickly, but they don't have a ton of endurance, so they can't do that for very long. For that reason, they're going to really want to wait for things to come along rather than go hunting after them. But they are really effective hunters because they have big, big teeth and sharp claws and strong tails. But they also have venom as well. So there's only a few kinds of lizards in the world that have venom. For a long time, they just thought that Komodo dragons had some bacteria in their mouth, but researchers have actually recently come to believe that it's actually another form of venom they have. So they tick pretty much every box for what it would take to be a fantastic predator. And Komodo dragons are a really, really awesome animal. And so I have time for a couple of questions here before we wrap up.
Great. We've got a lot of questions of what do they eat, and specifically, will they eat their own babies?
What do they eat? So the answer to the second part of that is yes, they will eat their own babies. Komodo dragons will lay eggs, but they aren't going to really stick around. Reptiles in general don't tend to be very, very attentive parents. They'll lay eggs and just kind of leave them be in a den. But baby Komodo dragons do definitely have to be worried about being eaten by larger Komodo dragons. That is why they live in trees when they're first hatched. But Komodos will eat pretty much anything that they can get their teeth on as far as the mammals that are native to the Komodo Islands, as well as some birds. It's going to consist of a lot of things, mostly things like wild pigs and birds, but they have been known to eat things as big as a wildebeest. So these are really, really large lizards, and so they can eat a really wide variety of things, but they also aren't particularly aggressive animals. especially not towards humans, so they are not going to be looking to eat people.
All right, I know we are just about the end of our time. I'm going to ask you one last question, and then I'm going to answer some more of those questions in the question and answer through text, so you'll be able to get those answers once we are done. But our last question is, why in the world are they called dragons? Does it breathe fire?
So no, unfortunately, he does not breathe fire, although that would be really, really cool. But they're called dragons because whenever Westerners first visited the Komodo Islands and saw these 10-foot long lizards, that was the first thing that came to mind. As far as living, breathing, real animals that we can see on Earth today, I really don't think there's anything that comes closer to a dragon than these Komodo dragons. They unfortunately can't breathe fire or fly, though.
Awesome. Thank you so much, Kevin, for sharing the Komodo dragon with us. We're going to come on back over to me one last time, and I'm actually going to end up passing it on to our host of the day. As I said, I will answer some more of those questions that you guys have put in that question and answer, so you'll be able to see them there. Hope you guys have a good rest of your STEM day.
Thank you so much, Colleen and Team Zoo Atlanta. We appreciate it and hope everybody enjoyed the live field trip. So right now we'd like to bring up GTRI, which is the Georgia Tech Research Institute, and they're going to talk about lightning. So I'm going to throw it over to you, Tyler.
Sounds great. Thank you so much, Heather. And so as Heather mentioned, my name is Tyler Kenner. I'm joined today by John Trossel and Dr. Levi Boggs from the Georgia Tech Research Institute, and specifically from the Severe Storms Research Center. So we're going to talk all about lightning and severe storms. This is part of our direct discovery program, of course, brought to you today for Georgia STEM Day. So students and teachers, if you have questions about lightning, about severe storms, please drop them in that Q&A panel in the chat. I'll keep an eye on that. But the real experts here today are John and Levi. So with that, John, I'm going to toss it over to you.
Thanks, Levi. Yeah. So the first thing I wanted to let you guys know is, how did I get to where I am today? I started out, I grew up in Massachusetts, and I actually grew up on the side of a ski slope. And I used to love the weather up in Massachusetts. I love the weather down here too. But when I was a teenager, I was actually, one of my skiing buddies was the head of what was called the Weather Bureau then. It's the National Weather Service now. But we'd go up and down the slope, and I'd get on the ski lift and we'd talk about weather. And I was, 12 years old. He was 60 years old, but the weather made us bond. So that was really cool. And when I was in high school, I actually had an opportunity to take weather measurements for the National Weather Service at my house. And you can still do this through something that's called the Cooperative Observer Service. When I got to go to high school, I was a geek. I'll admit it, I enjoyed it. We had a program in high school called Science Seminar where we did science fair projects. And one of the things I did for the science fair project was make what's called a quadrant electrometer, which measures electric fields in the atmosphere. And I did that for the science fair, and I did pretty well with it. I then went on to college. I got a meteorology degree from Penn State, and then I got a degree in physics from Clemson. And then Georgia Tech asked me to start working for them. And I've been working for Georgia Tech since 1983. So I didn't realize that. It's like 39 years. That's a long time. But I've done a lot of different things at Georgia Tech. I've done radar work. I've done underwater acoustics. I've done a lot of computer work. And now I do a lot of weather along with the computer programming, and I do a lot of outreach. Basically, I go to work and I play. So that's one of the things I want to say, you can study your math and your science and all that. And if you really enjoy it, you may be able to go to work and play for 39 years. So next. So we want to talk about thunderstorms. And one of the things that's, a real characteristic of thunderstorms is lightning. So how does lightning happen? If you shuffle your feet on the carpet on a dry winter day and then go up and touch a doorknob, you're going to get a little spark that comes off your finger. And that's because you're picking up electrons off the carpet. You put your finger out towards the doorknob, and that's going to attract protons. And when they get close enough, those charges are going to go from your hand over to the doorknob, and you're going to get a spark. So next slide. The same thing happens in a thunderstorm. Go back one. There we go. But in the thunderstorm, the things that are rubbing together is something called grapple, which is like a big spongy hailstone, and then ice crystals and water drops. And if it's in a colder environment, the grapple will actually pick up a negative charge, and the ice crystals will pick up a positive charge. And so as the grapple falls, the top of that cloud will charge up to positive. If it gets into the lower part of the cloud where it's warmer, the grapple will pick up the opposite charge. It'll pick up a positive charge, and the ice will, the snow crystals and water droplets will pick up negative charges. So as you see on the right there, the top of the cloud is charging positive, the bottom of the cloud is charging negative. So you get what's called charge separation there. So next slide. So the charges build up in the cloud, and that attracts opposite charges on the ground. And when there's enough difference between the two charges, you're going to get lightning that's going to go down from the cloud to the ground.
And so, John, just to jump in, this is like
Sure.
when, you know, if you have socks on and you rub them on the carpet and then you reach out and touch the doorknob, you know, you mentioned at the beginning, but just to come back to it, it's the same phenomenon, right? It's the same physics in a way, right? Where you've got that
Yes.
tiny spark happening between your finger and the doorknob, but take that and scale it up, multiply it by 1,000 or more, and that's what's happening between a cloud and the ground or a tree.
That's exactly correct. Yeah. And so the other aspect of thunderstorms that we often see is thunder. And lightning is the cause of thunder. You know, lightning is a huge spark, a lot of electricity. It heats the air to, as it says, 54,000 degrees Fahrenheit. That's hotter than the surface of the sun. And that causes the air basically to explode. And so as that air is exploding all along the lightning channel, it's making a big shock wave, which makes sound. And so you hear that sound from all along the lightning path, and you get a rumble. Now, if you're really close, you're just going to hear that one whack where that lightning was right near you, and it's going to overwhelm you. So thunder is caused by lightning.
And so I know, John, real quick, a lot of students,
Sure.
you know, might have the question of, you know, which comes first, thunder or lightning? You know, which do you see it first or do you hear it first?
Right.
Well, you're going to see it first, not just because light travels faster than sound, but because the lightning causes the thunder.
Exactly. You cannot have thunder without having lightning. Sometimes you're going to have lightning that's really far away, and you won't be able to hear the thunder. And people call that heat lightning, and they say, "Oh, well, you know, there wasn't. It's a different kind of lightning," but it's not. It's just lightning that's so far away that you don't hear the thunder, and you might not even see the actual flash, but you'll see the cloud get illuminated by that lightning, and that's what heat lightning is. It's just lightning that's far away and hidden behind the trees or buildings or whatever. So this is a slow motion video of lightning coming down from the cloud to the ground. And the thing that is neat is you can see all of the little fingers of lightning coming down. And once one of those gets close enough to the ground, what happens is a little bit of a spark comes up from the ground. It connects to that one path. And then you see it gets really, really bright when the return stroke, that we call it, goes back up to the cloud. And really what you see when you see lightning is that return stroke of the lightning going from the ground back up into the cloud.
So real quick, John, I want to pause for a second because you
Sure.
said something that kind of blows my mind. So the charges don't just travel from the cloud to the ground, but they go from the ground to the cloud.
Exactly. So you have leaders, they call them, coming down. And then once one of the leaders gets close enough to the ground, it's connected from the ground with a little short spark, and you get a whole bunch of charge going right back up that return path. And that can happen a number of different times. So you can get 3 or 4 return strokes up the same channel.
And so maybe the students have heard, don't stand near trees during a thunderstorm. Is that real advice?
Yes, I think our next slide shows this very well. So this is a somebody filming a thunderstorm out their backyard, and there's a lightning stroke, and then, whoa! So this is what happens when a lightning stroke hits a tree, and you can see it's just exploding a tree. So lightning is going to want to go and attach to one of the tallest objects, and the tall objects around are trees. So if you are standing next to the tree, the lightning is going to come down, hit the tree, and then jump off and might hit you with what they call a side flash. So that's why you don't want to stand under a tree during a thunderstorm.
And so, John, we have a couple questions. One is, so how do you get shocked? So if you were standing near a tree, or if you're standing outside in a thunderstorm in general, how do you get, how do humans become part of that equation and get shocked or electrocuted?
Right. Well, humans are really, big bags of salt water. So we're not as conductive as a wire, but we will conduct electricity. And so the lightning bolt will come down from the cloud and it might hit a tree. And if you're standing next to the tree, it's going to say, oh, there's a conductive path to ground. So it's going to jump from the tree and then go through you and then go into the ground. Or say you're not near the tree, but you're outside and you're standing there and lightning has hit somewhere nearby. Well, the lightning hits the tree and then it spreads out through the ground to dissipate, and you might be in that path. And so it might go underneath you, and where your legs are, you're gonna get a current of electricity through your body. So really, I think the slide after this really goes into some safety tips on how to avoid being one of those conductive paths. So the big thing is, and that's the catchphrase is, when thunder roars, go indoors. If you can hear the thunder, you're close enough to that storm that the next strike might hit where you are. So as it says, lightning fatalities in outdoor sports, 40% soccer, 27% golf. Golf's really particularly interesting because people put metal spikes on their feet and then raise up big, tall metal things above their heads. So they're trying to be as much of a lightning rod as they can. But basically, if you hear that thunder, like the kids are in the upper right-hand corner, leave the field immediately and then go inside an enclosed building. So you don't want to go to like something that just has a roof. You want to have a roof and you want to have walls. It's nice if there's wiring and plumbing so that the lightning would go down there instead of go through you. But if it's all enclosed, that's good. If you can't get to a building, go to a car, not a convertible, but a car with a metal top. Get in the car, roll up the windows, and just wait out. The car is pretty good because it's a metal cage that you're inside of. And then wait until 30 minutes after hearing lightning to go back, thunder to go back outside. So this is like what's safe and what's not safe. The safest is the building to go inside of. Sort of safe, not bad, is a car because it's a little metal cage. And not safe, obviously, is that tree or standing out by yourself in the middle of a field.
And John, we have one more question about lightning striking humans. This is from Miss Watkins' third grade class. So thank you for that. How many times have humans been struck by lightning? And you might not know that answer.
I don't know that answer. I do know that about one for every 10 people that get hit by lightning, only one dies. So people get hit by lightning and survive, which I think is shocking, amazing. But they end up with problems because your brain is really full of electricity, and so if you blast yourself with that much electricity, it's going to cause some problems. So there are problems both with it's deadly, but even if you don't die, it's gonna cause problems. There's a lot less lightning problems here in the United States because we have cars and houses and things, and but if you look at farming societies in Africa and such, where people are outside all day and they don't have access to these safe places, it's a lot more of a problem.
And so, John, I know our next slides are going to talk about some of the work that the Severe Storms Research Center does at Georgia Tech Research Institute. essentially to help keep us safe, right? To learn more about lightning, to better detect where it is and where it's striking and where those storms are. So can you tell us about the North Georgia Lightning Mapping Array and all of the stuff we're looking at here?
Sure, sure. So we have built up a system called the North Georgia Lightning Mapping Array, and it's you can see there are 11 units that make up this array, and you can see one down in the lower left-hand corner there, and you can see that sort of triangular thing up in the upper left-hand part of the picture. That's actually an antenna, and it picks up. So every time the lightning jigs and jags, it sends out bursts of static. And so you can hear that static. If you listen on the radio, you might hear crackles. So that antenna picks up each one of those bursts of electricity. It then goes down into that blue box, and inside the blue box is a little computer, and you can see the computer up in the upper right-hand corner there. And that basically analyzes that burst and tries to figure out exactly when it occurred. And then it sends that information back to a computer that's actually sitting right underneath my desk here. And so if I know exactly when each one of those bursts of static occurred for each one of those 11 different stations, I can come up with exactly where in time and space that little short path of the lightning stroke occurred. And so continually, every day, all day, this is measuring all those little bursts of energy. And you can see this here. This is from a storm in 2016. And you can see all of the little bursts of electricity that are happening from lightning in the cloud as this storm complex goes through Cobb County and Fulton County and Gwinnett County and just travels across the state of Georgia. And so we put this out, and you can actually go to this website yourself. The National Weather Service looks at it. And then we use it for research also. We store all the data and we can look at it later to try to figure out how the lightning affects the storms and how the storms affect the lightning. And maybe we can determine better when a storm is going to be a storm that has tornadoes in it or downbursts in it by looking at the characteristics of the lightning.
And so, John, students on the call might be wondering, is this like the radar that I see on the news, right, at night? And it's giving us the weather forecast for the next 5 days, and they show the radar, or they pop up the radar during storms. Is this the same thing?
No, this is different. It's actually, if you use them together, you can get a lot more information out. And that's actually one thing that we're doing right now, is we're looking at how the radar data, like you see on the television, how different characteristics of that might be in the same place as some of the lightning. So can we tell where the lightning is by how the radar looks? Can we use what the lightning looks like to tell us more about the storms than we can see just off the radar? Often in Georgia, the radar isn't in distinct blobs. So you can get these what are called supercells, and you can tell exactly where that storm is. We'll get these long lines of storms called squall lines. And inside there may be areas that have severe thunderstorms or tornado, and it's really hard to pick out. But if we look for areas of a lot of lightning, that can sometimes make us more aware that might be where a severe storm is.
And of course, these are tools that you're using as researchers and meteorologists, scientists, to learn more about storms. If students wanted to collect data or teachers wanted to collect data for their own classrooms, what are some ways they could do that?
Well, as you see there in the bottom right, we actually have developed an Arduino-based weather station that actually takes data and records it on an SD card. And you can actually put that SD card into a Chromebook, and you can analyze the data. So we had a 6th grade class at Otwell Middle School, and they actually used these sensors and looked at some online weather information to try to predict when cold fronts and warm fronts would come. So actually, I have one right here. It works really well. And we also go out and we'll talk to students also and give talks like this.
And so thank you, John, for this info about lightning, what is lightning, severe storms, how to stay safe in a severe storm, and a little bit more about how scientists can collect data and how students and teachers can collect data. Uh, Dr. Boggs, I know we're going to talk next, and of course want to give you an opportunity to share how you got here, but the one question I have on my mind is, we're talking a lot about lightning as we usually think about it, which is lightning that kind of bridges clouds in the ground that we see. But lightning actually happens a lot more often in the Earth's atmosphere than we might think about. Am I right?
Yes, that's correct. Yes, my name is Dr. Boggs, and yeah, there's a lot of weird space lightning that goes on that people really aren't too familiar with. And I'm going to share some exciting images about that. Just a brief background with me. I was always fascinated with electricity as a kid. What produces sparks? What generates electricity? And I'm sure a lot of you students have hopefully seen one of these, but they're very cool. They're called a plasma globe. That's that image to the right where the kid's putting his hand on the globe. And those are really cool. Basically, you have a really highly concentrated area of charge in the middle of that globe, and then the outer shell is glass. And so those little bright filaments you see are actually a plasma. And so when you put your finger on the globe, that plasma will go to where your finger is, because your finger, like John was saying, is more conductive than the air around you. I was blown away by that as a kid, and ever since then I was kind of obsessed with how lightning forms. And then as I got older, I realized there's still a lot of mysteries out there that we don't know about lightning. So then I studied a lot of meteorology and for my undergraduate degree in college, and then went and did my PhD in physics, similar to John, and investigated a lot of different things: thunderstorm charge structures, how that charge is generated, how lightning is produced, etc. And since then, I've been at Georgia Tech, and so now I work at GTRI with John there, and we have a lot of exciting projects. We're looking into some high-speed videos and things like that. And so this next slide is mapping of a flash from the cloud to the ground. So as John was saying, that North Georgia lightning mapping array will detect static from the lightning. And so what that array does is it can map out where the flash is actually going. So what you're seeing in this animation, you're seeing the sources in the sky. They would be in the cloud. The cloud is shown here. And then they follow that path to ground. And so it's pretty cool. You can map out in 3D space where exactly the flash occurs.
And so, Dr. Boggs, I want to ask one question. Maybe students who are athletes are on the call, or they've been to, maybe a high school football game, and there can be a storm off in the distance. It's not lightning right overhead, but you can kind of see it on the horizon, and the practice or the game still gets canceled. I'm thinking about that because I'm looking at this image and I'm thinking about the dark blue, which is kind of like the sky part. And then as it goes to the ground, that is not a straight down direction, right? It's going at an angle. And so how long is this lightning streak? And is that part of the reason why we have to be mindful of lightning, even when it looks far off in the distance?
No, yeah, that's exactly right. That's a good observation. So like he was saying, the dark blue in the cloud, that's where the storm would be, and that's where a lot of the heavy rain would be. And a lot of normal cloud to ground lightning does go to ground directly underneath that. But like Tyler pointed out, for this flash, it actually goes and escapes the side of the cloud and connects with ground far away from where that heavy rain is located. And in this particular flash, it was about 10 kilometers away. So that's about 5 to 8 miles. So,
oh, wow.
Really illustrates the point that, if you're under blue sky, as people call it, this would be a bolt from the blue flash, and that can escape the cloud. And, I've seen bolts like this travel as far as 10 to 15 miles away from the heavy rain.
Wow.
So yeah, they're really quite dangerous. So, if you're at a sporting event or something like that, and you're like, oh, well, the storm's over there, I think we're safe. A lot of the times that's not the case. And actually, these flashes are more common than we originally thought. And so we do have some work now kind of investigating how these things form.
And so we have another question from the Q&A panel. And so students and teachers, whoever's on the call, please share those questions. This one's really good. So thinking about the North Georgia lightning mapping array, and John, you might be able to help with this answer too. Does it map the reverse lightning? So earlier, right, we talked about the charges. The charges don't just come from the cloud to the ground, because electrostatics, the charges are going to work to meet each other. And so you'll have charges coming up from the ground through trees to meet the charge, in the sky. So does it map that reverse lightning, I guess? Although all of that really is just the same sort of phenomenon I think that we observe as lightning.
Yeah, it doesn't map that. Yeah, sorry.
That's right. Yeah, the North Georgia Lightning Mapping Array is very good at mapping the lightning inside the cloud. It is much less good at mapping lightning near the ground, because it actually sees that electricity or the static at a line of sight. So it has to be able to have a line of sight from that from the unit, from that antenna out to the storm where that lightning was. So it sees a lot up in the cloud, and it sees much less going down to the ground. We use different instruments and different techniques to look at that.
And John, you just mentioned, sorry, Dr. Boggs.
Go ahead.
No, you just mentioned something that I have another question now. So John, you mentioned lightning in the cloud. So there's a lot more lightning that happens than the lightning that we see striking the ground, right?
That's correct. Yeah, there's probably anywhere from 3 to 5 times more lightning in the cloud than actually from the cloud to the ground. And actually, Levi is going to show you that there's other lightning that doesn't go from the cloud to the ground, but it goes a different way. So go ahead, Levi, show them this cool stuff.
Yeah, for some reason that video looks like it's not wanting to play.
Yeah. Well, I'll tell you what, I'm going to put up this image really quick, and then I'm going to find that video from the Global Lightning Mapping Array, and I'll put that up here.
Okay, yeah, sure. Yeah, we can.
So
yes.
This is lightning that doesn't strike the ground that we don't necessarily see, right?
That's right. Yeah. So this is a whole class of events that people really aren't aware of, and they're called transient luminous events. And you can think of this as a space lightning. And so there's a whole plethora of different types of things there. I think there we go. So for example, there's lightning that shoots up from the cloud top. That's called a gigantic jet. That's right in the middle of the screen. And so that will actually escape the cloud top, propagate all the way to the upper atmosphere. There's gamma rays that get shot upward out of the cloud. And you see those bright pink, kind of like a globe. And so basically, if you have a really energetic lightning flash, that will shoot these gamma rays all up in this kind of uniform distribution upward away from the Earth. They first discovered those with satellites, and they were looking for these really energetic gamma rays from outer space, but they kept seeing sources coming from Earth itself. It was very puzzling. And so then with more and more research, we found out, oh, that lightning is actually causing those. There's these really big rings called elves at the top. I mean, these things are very huge, 10, 20, 30 miles in diameter. And they take place clear up around 80, 90 kilometers altitude. And so really these things are way, way high up there. But this is just a kind of an overview to show that, there's all this other electrical activity that takes place in the upper atmosphere.
And so, Dr. Boggs, we have here the Global Lightning Mapping Array video. Hopefully we can see that. So can you tell us about what this is looking at?
Yeah, so this was from a new lightning instrument that was launched in outer space. And so this is clear out in outer space looking down on Earth. And so what this can pick up is all the optical or all the light from the lightning flash that escapes the cloud and travels up to the satellite. And so all those bright gold flashes, those are light from lightning flashes. And you can see that this instrument has a huge field of view. So, there's all these storms, in this case, going across the United States, and you see all these flashes illuminating the cloud tops. And so this sensor is really a unique sensor in the fact that you can detect lightning from such a huge spatial domain.
And so, Dr. Boggs and John, we only have 1 minute left. And so I would love for you to kind of share your last second words of wisdom to the students, particularly those students who are interested in weather, have questions about weather, or maybe they find something else interesting. Maybe they found some animals from the zoo interesting, or something that come later on today during STEM Day.
Yeah, well, my point would just be, go to school, learn all you can, enjoy it, and like I said, if you find something you really love, then you get to go work for 39 years, and you get to play. And science is great if you like to play with things, because you're always trying to explore new things and new ideas. And that would be my advice is find something you can play with, and science is a great thing to play with.
Yeah, and likewise, I would agree with what John said. Find something that you enjoy doing, and don't be afraid to ask questions and to study different things. There's a lot of great scientists out there that in the past that they mess with things, like John was saying. They investigate different phenomena. And also, I would say, the younger you start to learn how to code and program, the better. I started that fairly late, so any resources you can for that would definitely help out later on down the road.
All right, well, thank you again, John, Levi. Really appreciate sharing your time and expertise this morning. And with that probably brings us to the end of our time. I see some questions in the panel. We'll type in some answers. Heather, I'm going to pass it back off to you.
Thank you so much, Team GTRI. We appreciate everything you have taught us today about lightning. So much. All right, so now we're going to switch over to Orizame with Med Girl Squad. She is going to be reading her own book. So Orizame, if you could come up on video. Welcome. I'm going to hand it off to you.
Thank you. Good morning to everyone that I cannot see, but I see that we have a lot of people watching in, tuning in. My name is Orizame Uye, and I'm super excited to be here for Georgia STEM Day. Super, super excited. And I absolutely love that presentation from actually one of my alma mater, Georgia Tech. So go Jackets. But I'm here to introduce to you all the Med Girl Squad, and I'm just going to go ahead and pull up my presentation. If my presentation wants to show up, there you are. Awesome. All righty. Well, happy Georgia STEM Day. And again, my name is Orizame. It is Nigerian, but people also call me Rezi. Super nice to meet you. And then other people like to call me Future Dr. Rezi, and I'll explain why. So I am 26 years old, not too old, not too young. I'm right in the good middle. And I am the eldest of 5 children. I have 3 little sisters, 1 little brother, and we just got our family dog named Simba. Could not secure a good picture of him because he just did not want to, he does not like pictures at all. So I didn't want to show a silly picture of him. It wouldn't do him justice. But my family is from Nigeria. And I am originally from Georgia, born and raised, but right now I am in medical school studying to become a doctor in Michigan State, at Michigan State University College of Human Medicine. But I'm super excited to be here to talk to you all about my journey. So here are a couple of things that I love. And for all the kids that are watching, hello, hello. You're going to get to know me very well through these slides. So number 1, I love taking pictures. It's my favorite thing to do. I also love to run. And in order for me to enjoy my favorite food, French fries, I need to make sure I'm exercising. But please make sure you don't eat a lot of French fries. It's not that good for you. So just eat it in moderation. But the other thing I like that's also a little bit more healthy is Korean food. Love, love, love that. Another thing about me is that I love drawing. And when I draw, I love drawing faces, and that's what you call portraits. I also love to watch movies, Marvel movies. So of course I have my Disney Plus. Marvel movies is one of my favorite things to do with my little brother. We watch it all the time. Cannot wait to see all the upcoming shows for Marvel. And last but not least, for all of my anime fans, I love, love, love anime. I've been reading manga since I was in middle school, and it's influenced the way I draw. So that's a couple of things that I like. Here's a couple of things I don't like. So number one, I don't like scary movies. Please, 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 please do not take me to any scary movie. I will embarrass you because I will jump when something scary shows up in the screen. So don't do that to yourself. The other thing is I really don't like spiders. This is probably the cutest spider I've ever seen in my life, but spiders don't look like that. And last but not least, this one I'm always getting in trouble with the kids, but hopefully you'll understand. Feeling very vulnerable about this, but I don't like chocolate. So I'm super sorry if I offended anybody, anyone who's like, oh my gosh, in the screen. So sorry. But the cool thing is, when it was Valentine's Day and I got a lot of chocolates, I would easily give it to my best friends. And so my best friends loved that I didn't like chocolate because they got all my chocolate. But that's a little bit about me. So one of the things that I like to ask everyone, especially the kids out there, is just think for a second. What do you want to be when you grow up? Just think about it. Put your thinking tanks on and think about it. A lot of times when I'm talking with kids, they talk about being a police officer. There's a lot of kids that want to be YouTube stars now, which is pretty cool. And then there's some people who want to be singers, actors, and there's a couple of people, one of my favorite people, who want to be doctors or who want to be veterinarians and stuff. So if there's anyone who'd like to share like what kind of things y'all want to be when you grow up, what you inspire to be, what's your dream job, please, please, please put it in the chat if you are able to. But then the question that I love to ask kids is, what do you think I wanted to be when I grew up? What did Rezi want to be when she grew up? And this is when I hope that the kids were paying attention when I was sharing about the things that I like to do. So when I was young, I'm seeing questions. Oh, yes, I see. I want to be a therapist. I got a doctor in here. Come on, come on. Yes, yes. I love this. Fantastic. Great. Artist. You're winning my heart. Okay. Unless that's what you're guessing for me. But if you are absolutely correct. I wanted to be an artist. So I've been drawing ever since I was 3 years old, and that was my first dream job. And here's a couple of things that I drew over time. So welcome to Rezi's gallery. Here's a couple of pictures that I drew. I did all of these on my iPad, so yay technology. I love drawing faces, portraits, and just catching people's special features and just showing just how amazing our faces are and like really paying attention to those details. But again, as now I'm in medical school, super, super confusing to people. They're like, how did you go from artist to doctor? What's going on here? Well, yeah, the thing is, I do want to become a doctor. That's me. Had a little change up here and there, not wearing my glasses, just wearing contacts, but repping my Michigan State white coat. But yeah, I wanted to be a doctor. But the thing was, at that time when I was young, like in second grade or so, I didn't know that I could be one. And so if there's anyone wondering, what do you mean by that, Rezi? Yes, I'm loving all of these people sharing their dream jobs. I love it. So I didn't know that I could be one. And I'll explain why. So this is me. Cute little Rezi, a little pudgy around that time because I was eating a lot of Burger King. Just being honest here. But my mom dressed me up as a doctor because it was costume day and I wanted to have the coolest costume, and I won the costume contest in my classroom. But I promise you that whole time when I was wearing that, I was just thinking I was wearing a costume. I never thought that I could become a doctor. And there's a reason for that. So let's do some math. Math was not really my best subject. So I hope this is going to be simple math for a lot of you people. And it just involves people guessing. So I'm seeing people put things in the chat. Please continue doing that. So let's say we had 100 doctors in one room. So in this case, let's say we were all gone and there was 100 doctors in this Zoom call, right? How many out of 100 doctors can you guess would look like me? Pick your best guess. Think about it. And then, okay, I see 50. 3, okay. 25, 2, a few, okay. Okay, well, I definitely saw the number that I was looking for. So out of 100 doctors, only 2 of those doctors would look like me. Right now, as of 2022, maybe a little bit more, but like only by 0.3%. Only 2.3% of doctors right now are Black women like me. And you know what? Now that I think about it, when I was young, I wasn't surprised by this, because when I was young, I didn't see a lot of doctors who looked like me. And I also realized that that was a big problem, just because not a lot of people, get enough care, and they're not relating to the doctors that they encounter. And also the other thing was, I didn't have anyone in my family who was a nurse or pharmacist or a doctor or anything. And then the other thing was, I just didn't really see it anywhere in the media, on TV, on the shows that I watched, and the books that I read, which became a huge thing for me too. What if I told you that there's a lot more books out there, like at least over 40% of books right now have a lot more books about animals compared to, characters of color, which was insane to me because I was a huge reader. Does anyone have AR right now? Do y'all know what AR is? It's like a really cool reading. Yeah, that is mean. AR is basically just the place where we were reading books and we would take tests and get some points at the end of the year. And my favorite thing was, depending on how many books you read and how many tests that you passed, you had to get a certain number of points to go to this huge book fair at the school that I went to. And I was like, it's a done deal. I need to read as many books as possible, which brought my mom so much joy. Oh my gosh, my child's reading. Wow. But I can tell you with my fingers that I can count how many books had a character that looked like me or was even interested in art or in medicine. So there was nothing in my reality that was pointing me to this. And that's why I decided, you know what? I love to draw. I love to play with kids because they let me be silly. And I love medicine. So why don't I take all of these interests that I have and put it together and make something that can outlast me? So I was like, let's make a book. And that is when the Med Girl Squad was born. So this is when I'm going to be doing the read along, and I'm really excited because there's going to be a fun activity at the end if we have time. If not, then I will be sure to send this to any teachers that are watching, that are participating in this activity. So let's move on to the read along. This is the cover of my book, Girls for Medicine. So for kids, I'm the author and illustrator. Author means that I'm the one who wrote the words in the book. Illustrator also means that I am the one who drew the pictures in the book. So I said I love art, I want to tell a story, and I put it all together, and this is the product. This is my baby. Awesome. Oh, cool, someone has it. Okay, well, hey you, what is your favorite class? If you asked us, then we would say Miss Star's science class. One day before our recess, she made one request. Take a second to lay on the grass and think about what you will do after my class. So we laid on the grass and we suddenly fell asleep. We dreamed similar but unique dreams. What do you think we were dreaming about? What do you think they were dreaming about? If you have an idea and you've been paying attention, you might have a pretty good guess, actually. Tick tock, and done. Medicine, healthcare. Yes, healthcare is our dream. We were proud to say that we for girls for medicine. That is why we are the Med Girl Squad. We each found a place in healthcare that was perfect for us. For Ava, she wanted to be a physician, the person who had the MD or DO at the end of their name. Dr. Ava would learn about the body, the heart, bones, skin, muscles, and more. Reading from textbooks to x-rays, she could learn why people get sick, why young and old people get sick, and find a way to make them feel better again. But Cindy, ever since her pet bunny got hurt, Cindy really wanted to learn how to care for her and other animals. So Cindy decided to become a veterinarian. Cindy the vet would treat both sick and injured animals. She could even do surgeries. She would treat birds, dogs, cats, turtles, fish, even elephants. Even animals need superheroes. Being a pharmacist was Naomi's dream. She was inspired by her grandma. Naomi's grandma took many pills every day. Naomi remembered how kind and smart pharmacists were to her grandma. Naomi, the pharmacist, would know which drugs would give other grandmas the energy to play with their grandchildren. Isabelle wanted to be a dentist. Dentists are the artists of the teeth and the heroes who take the tooth pain away. When people had icky cavities, Isabelle the dentist would put time and care to make their teeth healthy again. Isabelle just wants to give people their best smile. What made Gloria smile was becoming a physician associate, or PA. Gloria saw how a PA took great care of her abuelo, which is Spanish for grandpa. It was so cool. Gloria the PA could see sick people and even help with surgeries. Gloria the PA could work with kids or with the elderly later. Who knows? She could even work with Dr. Ava in the future. Can anyone spot Dr. Ava in this picture? It's my favorite thing to do. Look for Dr. Ava. All right. And Elena, oh, her heart was set on being a physical therapist. Ever since her dad had been in a wheelchair, she wanted to help him walk again. As a PT, she could help people move and handle their pain better. Elena, the PT, could teach children how to walk with their new legs. She could even help people train their weak muscles to become active again. After all, Elena was always excited to get things moving. Rose wanted to be an occupational therapist, OT for short. Rose also wanted to help anyone who is sick, injured, or disabled, especially those who cannot do everyday things as she can. Rose the OT would get to show people how to live their life with less pain, less confusion, and less fear. As for Susie, she decided to be an optometrist. An optometrist, the person who gives you new glasses. Susie the OD could do eye tests that tell her what's wrong with your eyes. If someone wanted to see better without glasses, then Susie could give them contact lenses. Her eyes always sparkled when she daydreamed about being an OD. Finally, Lauren dreamed of becoming a nurse. Nurse Lauren. She could give people their medications, sit with them at their bedside, and use her brain to help out the doctor, like Dr. Ava. Nurse Lauren would run the extra mile for her patients. Nurse Lauren would see patients and be their greatest superhero. Well, what about you? Are you kind, smart, passionate, caring, thoughtful, active, understanding, helpful, organized, a good listener, problem solver, a leader? Do you like science? Do you like solving puzzles? Do you like asking questions? Do you like being an investigator, helping people feel better, making a difference? Do you want to be a real superhero? Then healthcare needs a girl like you. Yes, there is plenty of room. You could be a girl for medicine like us. This could be your future too, your dream. Until then, stay in school and be an excellent student, learn science, and also very important, be kind to others, help whoever needs help, be a caring leader at home and at school. Most of all, just be you. See you soon. And that is the end of my book. Thank you so much for your patience and your attention. I know that was a lot of jobs to sift through, but this is my favorite activity. But basically, this book was just about meeting the MedGirl Squad, who are each different, interested in something different in healthcare, because a lot of kids may not really know all the options that you have. So, oh, sorry. See that there's questions. But okay, so this is my favorite part of the of my presentation. So again, I love to draw and I'd love to give kids an opportunity to help me create a character. So why don't we try to make a character for Georgia STEM Day? And I'm going to need the help of some teachers that have kids watching right now. If there's any way for you to ask your kids, okay, what do you think this character should be? What should their name be? This is when the chat's going to be really, really helpful. Because I know we have only maybe like 9 minutes to go through this. So what I can do is just make a list of all of the requests and then send it to whoever is participating in creating this character with me, just so I can be respectful for all the amazing presenters for Georgia STEM Day. Okay, so the rules are you have to be creative. Number 2, 1 suggestion per person if there was just a class. This is only going to take me 10 minutes if I had the time. But number 4, be creative. So I would like to know what this character is wearing. What's the character's name? What color is their eyes? What shirt are they wearing? What are they doing? Are they like singing? Are they dancing? Sure. Okay, I see dress from Mrs. Poland. Let me note all of this down. Ooh, there you are. Okay, Park Elementary in Hamilton, Georgia. Eye color will be green. Okay. Our character's wearing a dress, has green eyes, who is singing. The children's nurse wearing a minion outfit. Wow, you went straight to the description, huh? Okay, her name is Brooklyn. Long brown hair, got it. Jefferson Academy demands for the lab coat. Of course, of course, of course. Glasses, boots, awesome. I'm already seeing this character in my head. I'm already seeing Brooklyn. Hat, ooh, what kind of hat? She is busy. She's doing all types of top hat. Got it. Ooh, I love this participation. Full name, Brooklyn Layla. Awesome sauce. Okay, and I did see a question about when did I publish this book. Sorry, I didn't see there's a whole bunch of other questions here. But basically, I published this book about 2 years ago, and this year I had created a special edition to reveal my next book idea. So I know it's called Girls for Medicine, but if you were able to see the last few pages, you know what my next idea was. Okay. Ooh, Georgia Tech pendant. Oh, of course. Of course. We have to do that. Okay. What inspired me to write a book? Well, I really loved writing stories on my own on my little computer when I finally got my own laptop. And I love the opportunity that someone can be reading your story from years to come and feel encouraged by what they're learning in the book and believe that they can do it, especially when they meet the author and illustrator who's doing what she's, encouraging the readers to do. So love these questions. Okay. My sticky note is full of ideas. Green Crocs. I feel like we have to have two characters in here. Oh yeah, stethoscope, of course. Okay. Thank you all so much for these amazing ideas. I wish I had like a full session with y'all to put it in. But okay. All right, so I have enough information for me to create a really cool character in celebration of Georgia STEM Day. But in case you're wondering, this is when I would have showed you my character, but we don't have enough time. I'm so sorry. But thank you. And I've already been answering some of the questions. And if you're at all interested in learning more about Girls for Medicine and actually meeting real people who are part of the Med Girl Squad, I highly encourage you to definitely visit our social media platforms, especially our YouTube channel, where I have been interviewing actual women in medicine who are part of the Med Girl Squad, and they're sharing their journeys from veterinarians to optometrists to physicians, orthopedic surgeon. That's coming up soon. And if you'd like to learn more about this book and about me, please do visit our website. I really do appreciate everyone's attention. And I can take more questions since I do have like 4 more minutes. Okay. Ooh, what is my favorite book? Oh, that's a tough question. Demetrius Bryant asked me, what is your salary? And I don't have a salary. I am a student in medical school. And what is my favorite book? I would say one of my favorite books that I'm reading right now is called Amari and the Night Brothers. It's a chapter book, fantasy. Really, really love it. And how long have I been drawing? I've been drawing since I was 3 years old. And then Nicole Chambers asked, what kind of doctor are you going to be? Great guess. That's actually what I want to be. I want to be a pediatrician, which is just the doctor who cares for kids, babies, and teens. And what app did I use for this? So the app that I use to create my illustrations is called Procreate. And it's a really, really great digital art app. So if you have an iPad, then you can be able to create things like this. I answered it. Where can I find your books? Yeah, you can just go to this website that's on the screen right now, Girls for Medicine. How long were you an artist for? Yeah, since I was 3. And I hope you can see that you can pursue more than one thing. If you're interested in being a YouTuber and a librarian and also a veterinarian at the same time, it's possible. It might be a little bit challenging, but if it's something that you're passionate about, then you'll find a way to make it all work. Who inspired me when I was young? I know it's silly, but might not be silly, but the person who inspired me the most is my mom. She's the one who helped me see that I can pursue more than one thing. And she always encouraged me to do my best in whatever I was trying to do. And my favorite color is this color. I don't know if you can see that. Yeah, this color. I think it's a turquoise. Oh, it disappeared. Oh, I love these questions, and I really appreciated everyone's participation. And the college that I attended was Georgia Tech, and I studied biology. Where do I plan on practicing medicine? I have no idea yet, but I hope it'll be somewhere warmer because I miss Georgia's warm weather. Michigan's so cold. And absolutely, I am going to write a lot more. I have many stories to come, so sit tight. Okay, I think I answered all the questions so far.
One question, are you shadowing anyone in your field?
Oh, am I shadowing? Well, I did that when I was in college. And now that I'm in medical school, we get to go to the hospital and meet different doctors doing different things. Like ones who are caring for people with heart problems, we go see the cardiologist. Or if there's someone caring for people who have lung problems, we go hang out with the pulmonologist. So I've been able to meet different physicians and follow them around to see what they do on a day-to-day basis, because eventually I might do something that they're doing. But I'm pretty sure I'm going to be a pediatrician.
Well, thank you so much, Orizime. We appreciate you taking time out of your day to read your book and afterwards creating our STEM characters, right? So many thanks. Hopefully you will be able to post them on your Twitter and connect with us, tag us, and use the hashtag Georgia STEM Day so everybody can see what they have created. So thank you so much. We appreciate your time.
Thank you, everyone. Enjoy Georgia STEM Day. Woohoo!
Have a great day. All right, everyone. We are now going to bring up Akil Shaw. He is going to introduce game design. And so if you will, come on up, Akil, we'll get started. Thank you so much. The floor is yours.
Good morning, everybody. My name is Akil Shaw. How you doing? How you doing? My name is Akil Shaw. I am a junior music performance major from Atlanta, Georgia at Morehouse College, and I am representing STEAM Sport today, this morning. And today, I will be teaching you all about Scratch. So I'm going to share my screen and we can follow along as we go. Let's see. I hope everybody can see this well. Let me move it over some more. Okie dokie. So we're going to start off by going to scratch.mit.edu right here in the search bar. All right. So I'm going to briefly talk about Scratch. What is Scratch while everybody's pulling it up? Scratch is the world's largest coding community for children, you all. And it has a coding language that has a simple visual interface that allows young people to create digital stories, games, and animations. So starting over here, we're going to pick a sprite, which is basically our character that we're going to be coding in this game. So if everybody's there, I'll give you a couple more seconds. If everybody is there, we're going to start down here where it says choose a sprite. It's a little cat with a plus sign over his right ear. So loading a little bit. Here are all your sprites. You can also upload sprites once you get more familiar with programming. You can upload your own sprites, pictures, or anything of the such. But we're going to start off with Abby. Abby, I'm going to delete the cat. So we're going to use Abby as our character. Now, what is Abby going to be on? Let's choose a stage, all right? So how to choose a stage. We're gonna go over here, right where we just chose the sprites, to the left, to the right of it. I apologize. We're gonna have backdrops. So Abby, let's ask the chat. Where do we want Abby to be? We want her to be castle, a nice bench in the a nice bench in the park. At a concert. Let's see. Castle. Okay, I see castle. Let's go. Let's choose this castle, castle number 3. All right, there we go. So we have our character, Cassie, and our backdrop, the castle. Now, we are going to make Cassie move across the screen. This is going to be using the X and Y coordinates. So over in this area, this small box to the left where the visual TV screen is, that's what we're going to call it, this TV screen. You're going to see these X and Y coordinates right here. So this is where Cassie is at the moment right now. I keep saying Cassie, I mean Abby. She is right here. But notice when I move her and place her over here by the steps, her X and Y coordinates change. They change to -1, 2, 3, and 7. So I'm gonna start her over in this left corner at -188 and -73, right? And I'm gonna make her move over here, all right? So starting over here, moving to the right side of the screen, this way. Now we're gonna be moving over to our motion blocks. We're gonna grab a move 10 steps, about 10 steps sounds cool. The motion blocks are over here in the coding. So if you're right here in the costumes, make sure you click coding so you can grab all your motion, looks, sounds, event blocks, and stuff like that. So we're gonna grab a move 10 block, move 10 steps a block. Doing this, now we're gonna just go double click it, see what happens. Oh, okay, we have some movement. Let me do that again so you can see it. Okay, so 10 steps does not seem like enough for Abby. So I'm gonna type in, say a random number, 50. So we have 50 steps, let's double tap it, see what happens. Okay, hold on now. 50 steps, okay, that's cool, that's cool. But I want her to get maybe about this much down the hallway. So we're gonna start, I'm gonna type in 100 steps. Okay. Oh, that's nowhere near enough, is it? So instead of typing in all these steps, right, I'm gonna show you guys a shortcut. I'm gonna grab this glide block. This glide block is also in the motion, underneath motion blocks, the first one at the top. You're gonna scroll down till you see it. It says glide 1 second to X coordinate and then the Y coordinate right there. So we're gonna grab this and for about, I'm gonna say just 3 seconds, she's gonna move. Remember where we started, these X and Y coordinates right here. So she's in this corner. She's at -191, excuse me. Okay. She is at X the X coordinate, I'm sorry, is -191 and the Y coordinate is -66. So remembering that, those coordinates right there, we're gonna place her right here where we want her to end up at, which is 193. I'm gonna type these in this box, 193, and Y coordinate 34, right? Now remember, you have to reset Abby because these are the coordinates we want her to go to, and these are the coordinates that she's starting at 194 -7. We're gonna double click this and see what happens. Oh, we have motion. Let me do that one more time. Not too bad, not too bad. So I'm gonna just put this back. So we're gonna use this glide block using the X and Y coordinates, right? Now, if we want to just like press play or something, or press space bar, space bar, and then she goes automatically over there to this right side of the screen or down the hall in the castle. We need to add a control block. So we're gonna scroll down 1, 2, 3, 4, 5. It's the orange one. I'm gonna grab this control block and we're gonna say, oops, I apologize. I meant events. So we're gonna go down to the fourth one, the yellow. They kind of look the same, but the fourth one, it says yellow, and we're gonna grab when space key is pressed. So now we're gonna click it on the top of that and press space, see what happens. Boom, we got it move. Right, hold on, let me check the chat to make sure no questions. Okay. Time. Nice. All right, look at us. We're coding. All right. So now we have our stage, our character, and our backdrop. And we're using the X and Y coordinates, remember, down here. I want you guys to experiment with this a little bit. I hope everybody's there. Ask any questions if you need to. And I'll take like 2 minutes to answer questions or anything like that. If anybody has any. Oh, I see. Oh, I apologize. I'm just not seeing these. Can you give the website again? Yes, I can. The website is Scratch, right here. Scratch.mit.edu. Yeah, just you one. Right. How did I decide to begin coding? That's a good question. So, I have to think back. I think it was summer going into my junior year in high school. There was a program with Georgia Tech that came over. One of the coding professors from the College of Computing came over to teach an AP class, AP Computer Science. So I just took it because it was a new class, honestly. It was fun, it was. And I just kind of like, I guess, kind of continued it. And working with STEAM Sport gave me an opportunity to learn it twice because I have to teach it to other students as well. So I enjoy it, honestly. So I see another question. What do you want to be when you grow up? Okay, so I play instrument. I play tuba and the bass in jazz band. Tuba is my primary instrument. So I want to be a orchestral player, movie scripts, anything where I'll be playing the tuba in the future is okay with me. So gigs. In the bass jazz band, we already do like at Morehouse, we already do small gigs. We just performed at Candle in the Dark, Valentine's Day. I'm a musician, so anything, it's kind of hard to pinpoint exactly what's going to happen in the future, but you just have to be open and ready for whatever comes at you. Do I know how to create a Fortnite? I do not know how to create Fortnite. However, using Scratch, let me come back over here. Let me go to our backdrops. There are plenty of backdrops that you can choose from. You can even upload your own. So a Fortnite, I'm not really sure what Fortnite backdrop would look like for Fortnite, but you can download it and upload it, like just how we just did this one, and use your characters to glide across the screen. So remember this one right here, if you want it to be smooth, unless you just wanted to take 10 steps, every time you press space, you're going to use this glide bar. Enter in the number of seconds, the X and Y coordinate of where you want her or him to go, and boom, we have movement. Let me check my time. Okay, I'm good. What, I have another question. Have you ever created a game? Yes, I have created a game. I was actually pretty proud of it last summer when I was teaching coding. I tried to find it earlier, but I could not find it. I think I forgot to save it or something like that. But it was like a baseball game. You had to swing in motions of the characters. I'm going to show you a little bit on how to do that. What is your favorite instrument? My favorite instrument is tuba. To play, well, my favorite instrument to play is tuba. I think the most like beautiful instrument though to me is the French horn. Just hear, it can cut through a band, it can blend through, it can blend in with what's going on, and it's just like, it's a beautiful instrument, honestly. Yeah, French horn, definitely. Any more questions? What is your favorite game? Oh, you played trumpet, Jacob? That's dope. That's dope. Oh, I'm sorry, just saw that. How do students log in? Students, you do not have to log in to use this website. You can just go to here. If I log out, well, wait, I'm not gonna log out right now. But if I'm not logged in, it's still gonna have that create button all the way to the left. You can press that and then it's free. So you're gonna be able to, use upload everything you need to. However, you will have to go here, file, save to your computer so you can, come back to it later on. What is my favorite game? Oh, what is my name? I'm sorry, Akil Shaw, AKIL SHAW. What is your favorite game? I don't really have a favorite game. I don't play too many games, but I'm pretty good at 2K. So if anybody, wants to hop on with that, we can do that. Do I play sports? Yes, I do. Tennis and swimming. I played those in high school. I still play tennis every now and then, but tennis and swim, those are my main two sports. I also play basketball. That's just for fun though. I never played like on a team for real. I'm a good center though if you need a pickup. Can I make Abby play an instrument? That is a good question. Let's make Abby do some more stuff besides glide across the screen. So to change Abby's costume, she has 4 over here. I apologize if I'm moving too fast. Right here next to the code, we're gonna go to the right and go to costumes, right? To see what all Abby can do. Let's see, okay, she has a thinking face. I'm not really sure what that is. I'm gonna choose a different sprite, one that has a little bit more action. So let's say what? Okay, a batter. I like this. All right, bye-bye, Abby. I'm gonna change my backdrop. Since we have a batter, I'm gonna change it to baseball. Baseball number 1. All right, so here we are. All right, here we are. Now, with the size, Abby's a little too big for this home plate, so I'm gonna just drop her down maybe what, 75? That looks good, that looks good. All right, so now still same thing. We're gonna go to costumes right here. Okay, yeah, so we have more action with this one. We have one where she's about to hit it. This looks like she's hitting the ball and the follow through. Okay, I like these. I'm gonna go through this a little quick, so just bear with me. So let's see, looks. So underneath looks, we have our switch costume button. You have to scroll down to find it a little bit right here, switch costume. So remember our costumes, A, B, C, and D. They're gonna be listed underneath this drop down right here, A, B, C, and D. So starting off with swing. Okay, she's like that. B is, okay, no, B is starting off the swing. C is hitting the baseball. And D is the follow through. Okay, so we're gonna start with B as in boy. I'm gonna use one of my event blocks again. You're gonna be using about one event block for every action that you want to happen. So when you press space, the costume switches to batter B. Now, after she swings, she's right here. We wanted to follow through. However, we need a wait second block before she follows through. So about wait 1 second, and then she's gonna switch to the other costume, if that makes sense. I'm gonna go to looks again, grab another switch costume block, go to the drop down and click C. All right, let's test it out. It's always good to, as you're moving, don't just try to put all the code down and then press play. You're gonna wanna test it as you go. It's kind of a learning experience. So you just gotta play around with it and see what happens. Let's see. Okay, that looks good. Do it one more time. Boom, all right, so let's get another wait second. We'll do 1 second, one more. Another look block. Another switch costume block underneath the looks. Okay, and then switch to costume B. All right, let's try it. And then follow through. That looks good. Now, what is she hitting? We need to add a baseball. Let's see. Oh, here we go right there. All right, this baseball is way too big. So I'm gonna come down here again, type in what, about 30. This looks about the same, good size for a baseball. All right, now using those glide blocks that we used in the beginning with Abby over in motion, where is it? Right here. We're gonna grab a glide block. If you're wondering where the code just went for our baseball players, right here, you switch back and forth between the sprites to see, where the code is for each one is specific. So we're gonna use this glide block to make this baseball move. Let's see, so if she makes contact right here, let me press space. Okay, she makes contact with the ball about right here. This coordinates -57 and 45. So that is where it's starting, right? When she hits it, we need it to go, let's say, over to the right, over here. These coordinates are 187 and -146. So we're gonna type these in right here because this is where we want the ball to go. 187, -146, right? All right, let's test it out. Okay, that's nice, that's nice. We have movement. I'm gonna go back over here and count how many seconds that it took for her to make contact. So if I press space, that's 1. Okay, she makes contact right there. So after 1 second, the ball should start moving. So I'm gonna come back over here, go to controls, add another wait 1 second block on top of my glide button, my glide block, because after she waits 1 second, then the ball is gonna move. I mean, after the wait 1 second, the ball is gonna move. I'm gonna go to events, grab space bar, because once I press space, because both of these are space bar, when the space bar key is pressed, both of them will start activating at the same time. So we're gonna try it out. Let's press space. Good swing at one more again. Oh wait, hold on. So we see a dilemma, right? So this is just kind of how coding goes. You live and learn. So after she swings the ball, boom, good follow through, the ball's over here. But if we want to do it again, we press space, the ball is still over here. So I need a motion block. I'm going to program this ball to go back to this space right here every time that I press space or restart it. So I don't have to physically move the ball. That's, you know. So the ball is right here. I'm gonna grab this go-to block in motion, put this at the top. Go to, what coordinate are these? Negative 73 and 30. So now what this is saying is that when I press space, the ball should go to these coordinates, wait 1 second, and then glide across the screen. So we're gonna try it out. Okay, we good. We'll try it again. Oh, there we go. Look at us, we coding. Any questions with that or anything you guys want to see? So we got like 5 more minutes before we bring up the next panelist. Let me check the chat. Basketball. We don't really have enough time to do basketball for right now. However, using, you know, the backdrops, using these backdrops over here, you can upload. Let's see, they have about 2 basketball backdrops that you can use or upload your own as well. And the basketball sprites and stuff like that. Let's check the chat. Any other questions? Mr. Smith on 2K, I got you. Let's see. Oh, what is your favorite sport? Okay. To play, my favorite sport to play is tennis. I just love you gotta have good footwork in tennis. Like you're always moving and the match is, I mean, sometimes they time the matches, but like you only have like an hour to play. But really you can play all day on one match. If it goes back and forth, deuce, add in, add out, deuce, add in, add out. You can really be on the court all day. And I just like the variables in it. Like it's so many ways. You can, of course, you have your forehand, your backhand, your serve, your volley, and stuff like that. But like the possibilities of where the ball can go, you know, it's just endless. It really is. I like it. I like you can really do anything and still win, even with little experience.
You're being asked, what are the pros and cons of coding?
Pros and cons of coding. Okay, so everything technology-wise is coding. So this computer that, let me dig in even deeper. This Scratch website has coding in it. Somebody coded all of this. in order for us to code this. So the pro, let me think of a pro. A pro, you'll know how everything works and see how the process of elimination scales. If I wanted to do this, I can come here, find like glad this right here, press space. Oops. Well, the learning coding is like the pro. I'm trying to explain this right. Hold on, excuse me. Learning coding, it gives you other thinking skills, right? So process elimination, just going through stuff in order to figure out, what you want to do. So process of, my apologies.
You've also been asked, how long does it take to do or code a full game?
So it depends on what game you want to code. So you see, it took us maybe what 5 minutes to code our baseball player. Once you get familiar with all of the blocks and stuff like that, you'll start moving, and what you want, if you're clear with what you want to happen on the screen, it'll be easier as you go. So in the beginning, maybe about 30 minutes to code a simple game like of baseball or something like that, changing backdrops and stuff, maybe about 30 minutes. Now, if you want a more complicated game, like you're using the arrow keys, collecting coins, like something like Mario or something, probably about more than an hour. Of course, once you get familiar with all your blocks and stuff like that. So I say about an hour. For me, it might take about an hour. Do I have any other questions?
I think we're good for now, but please stay on, Akil, and ask any questions that might be in the chat field. We really appreciated your demonstration of Scratch and your time today. Thank you so much.
Thank you. All right, have a nice one, everybody.
You. All right, everybody. We are going to pull up Princeton Rose. She is with Hype, and she is going to demonstrate how to program a rock, paper, scissors game using Scratch. Princeton, can you come on up?
Yes, I can.
Perfect.
Hello.
Thank you.
All right. Then I think I can share. Oh, cannot share my screen just yet. I think somebody else is sharing their screen right now.
Sorry about
Okay,
that.
all good.
Cool. I see there's a lot of people active in chat, so that's good. All right. All right. Hello, everyone. So go ahead and open up the chat here. Cool. So hi, I am Princeton, and I'm going to be talking about Hype's ultimate guide to programming a rock, paper, scissors game with Scratch. So I did see that somebody was asking how long it took to make a fully programmable game or a full game. So actually, that's what we're going to be doing today. We're going to look at how to make a game with Scratch. But first, let's talk a little bit about me. So hi, I'm Princeton. Right now, I'm a lead instructor at Hype. I really enjoy coding and teaching, which obviously I'm here, and that's what I'm doing. I'm a huge gamer. I'm a nerd. I love anime, and I love reading. Nonfiction, fiction, doesn't matter as long as it's interesting. And despite the fact that I'm really into computers, I actually do really enjoy being outdoors. Being outdoors is important. Fresh air, hiking. I love hiking. So what is Hype? Well, Hype is a nonprofit organization where our goal really is to help girls and women get more into tech, because if you haven't noticed, the industry right now is very male dominated. So we have a whole bunch of activities, camps, after school programs that are designed to help girls get the skills, become more familiar with tech, and help them break into the tech industry. Cool. So some things that we probably want to think about, right, while we're doing this. So what is computer programming? Many of you will have like questions about that. Maybe some of that was answered before, so I'll go over it briefly. We'll talk a little bit about what Scratch is for anybody who might just be tuning in, how you can program rock, paper, scissors as a game, and then some of the things that you might need. All right, so just a quick overview about computer programming. So programming is basically just a set of instructions telling a computer what to do, right? There are many different languages that we use. So you might hear of like Python or Ruby, JavaScript, Java. There's like a ton of different languages that we use to tell a computer what to do. And you can think of a computer a little bit like a super, super, super obedient dog. This is both a good thing because it means that the computer will do only what we tell it to do, and kind of a bad thing because sometimes when we tell it to do some things, like it has to do that and it can't make a decision. Like if you told somebody like walk into a ball, they might be like, no. So what is Scratch? Maybe this was covered before for some of you, but Scratch is basically a block-based programming language. I like to think of it like Legos, like you snap little pieces together to put code together for the computer to read. It's the world's largest coding community for children, which is great. It's a lot of fun. And like I said, I love Legos. So you will need a Scratch account to like do this, but it is free. So don't worry about that. And it's a lot of fun. So 4 things that we need to think about when we have a programming language is that it's going to run in a given order, right? Most computers typically read like top to bottom, left to right. So keep that in mind. Another thing we want to do is repeat steps. You don't want to like have to sit there and tell the computer every single little thing to do. If you think about your own life, right, you don't want to have somebody standing behind you like telling you what to do every step of the way. You want to be able to just kind of like give a set of instructions and then have it follow that, and then have some way for it to go into our next one, which is make choices, right? How is it going to make the decision on what to do next, what to do when certain things happen? And then we need to save information, right? If we think about it, memory is like really what separates us from many other things, right? We remember things that are good, things that are bad, things that happen, and we learn from that. So let's get into this really quickly, right? The fun part, the actual building of the code. So over here, I have a window. I've got a document here, and you can find these documents. We'll have this available for you later. That just kind of walks us through like what we want to think about when we're doing this game. We're going to use some variables to store this. We're going to definitely think about what we need to bring in, like our inputs, and what we need to put out. What outputs is like what we're displaying or feedback we're giving to the user, right? And then just a couple design decisions here and some things here. I kind of know what this is, and we do have a limited amount of time, but I also want to let you guys have time to ask a lot of questions and all that. So let's get into it. So this is Scratch. So once you've made an account for free, it'll bring you here. This is your dashboard. And what we want to do is we want to make a new project. So you just pop up here to create, and it should take us to this little screen. Haha. So when you start here, it's kind of blank, and you've got this cute little cat, and this is a sprite. And over here, we have like the blocks. So if I like pull this block out, we can see it has little grooves, and then I can pop another block on there, and it snaps on, and you can snap it off. It's a lot of fun. And you can just drag them back if you don't want them. Now we're doing paper, rock, scissors, so I kind of don't need a cat, right? The way Scratch works is that you can attach instructions to a character, right? Like if you think about a character in a story, have it perform it. So for me, I'm going to be playing against the CPU. So let's see if we can find like a sprite that is a computer. So type in computer, cool. So I have this thing, a laptop, and then here you can like drag it around. And it shows down here, it shows like what the sprite is called, and we can rename it. So I'm actually going to call this the CPU, right? And then you have like the size, and you have like direction. You can edit all of these. So let's see, I'll make this a little bit bigger. Yeah, cool. And as you can see, I have the CPU selected, and up here in the top corner, it shows me like what I'm working on. So the first thing I really want to do is we need to have some way of storing how the player is going to choose and how the CPU is going to choose what they're doing. So down here, we have on the left side, we have this thing called variables. And I'm actually going to say you can actually make a new variable. So I'm going to make a variable, and this one's going to be the player's choice, right? What did the player choose? Because if we think about it, right, this is rock, paper, scissors. I need somewhere to save like what the player chose. So whether it was rock, whether it was paper, whether it was scissors. And then I'm going to make another one, and this is going to be the CPU's choice, right? Because the computer also needs to choose rock, paper, and scissors. And then later we're going to have to compare like, hey, who won that bout of rock, paper, scissors? Cool. So let's add some sprites. So right now the player has no way of actually like, interacting with this. So we need to actually add something in. So, whoops. Let's go ahead and get, let's see, a rock. Cool, right? So I'm gonna have that there. And then I can look to see if they have paper. Okay, so no paper. What about scissors? All right, so we don't have any paper, any sprites for paper, and we don't have any for scissors. So Sprite has this really cool thing where if I want, I can actually upload a Sprite. So I'm gonna go ahead and do that. I kind of did this before by accident, but yeah, it looks like I already have. I went out on like Google and I found some free images, and so I found one for paper, and wow, that's pretty big. So let me tone that down a bit. Right, and then let me go ahead and get one for scissors. Cool, let's tone this one down a bit. All right, and maybe make this paper one a little bit smaller than that. Yeah, I'm just gonna drag them. All right, cool. So now we have actual physical representations for the player on like rock, paper, or scissors. Right now though, when I click on it, nothing happens when I do any of these. So in order to swap between like what sprite I'm currently programming, I want to click on the sprite down here. Now, like I said before, you can see up here where we are. So here we're on the rock. So one of the things that we can do is we need to make it so that when I click on this, I send some kind of like signal that lets the computer know or the game know that like we as the player chose something. So coming over here, looking through all of this, I have what's called events, right? Which is when things happen. If we want it, I can actually put a quick event, let's see on like the CPU. That says like when this flag is clicked, which is here, let's have it say something really quick. Yeah, say hello for 2 seconds. Let's see how that works. Haha, as you see a little speech bubble comes up and the computer spoke to us. Cool. So I'm going to do something very similar with my rock, my paper, and my scissors, except I'm going to use a different event. So I'm going to say when this sprite is clicked, right? Because I'm going to allow the player to just click on this to choose which one they want. I'm going to say, I'm going to broadcast something. I'm going to say a new message because it does have some default message, but we don't want that. I'm going to say that the player has chosen, or the player chose, right? The player made their choice. And so I'm on rock. And if you remember, we had these variables here, right? Where we're going to store what it was. So I have this here for setting it. And I'm going to say set the player choice to, and actually I can type anything I want in here. So I could type like a number, but I just want to type rock because that's what we're choosing. So I'm going to go ahead and say, hey, broadcast that the player chose, right, something, send the signal that the player made the choice, and then we're going to do something with that signal later, right? And then if I want, I can actually duplicate this. I can say, hey, let's see if I can put it in our paper. I don't know if it went in there, but we can make it again. So let's go ahead back to our events. Let's say when this sprite is clicked, I'm going to broadcast player chose, and then I'm going to go ahead and I'm going to set my player choice to paper. And we'll come up to our scissors. I'm going to do the same thing. Where are you, events? Okay, when the sprite is clicked, it's going to go ahead and broadcast that the player chose. And let's set that variable again. Let's set our player choice, and this time it's going to be scissors. All right, cool. Cool. So if we look up here, when we make these variables, they have these little checkboxes. We can actually turn them on or off so that they're showing in the game. Now, one of the things that you should do typically when you're programming is you should always be testing your code, right? Write a little bit of code, see if it works, write a little bit more, see if that works, right? So right now we've done a very small amount. So when I click on one of these three, it should change whatever the player choice was to whatever I clicked on. So let's see if that happens. So I click on rock and we see that it changed to rock. I click on paper, I can see that it changed to paper, and I click on scissors and I can see that it changed to scissors. All right, cool. So we know that that's working now. We know that now we have the ability to actually change what the player's choice is. So now that we've saved that variable, all we have to do now is just get the rest of the game. So we're going to come over here to our CPU. Now, if we think about our events are broadcasting like a signal, so we're sending a signal out, so that means somebody's got to receive it, right? So we probably want our computer here to receive that. So if we go over to our events, we actually have one for, hey, receiving the signal, right? And it's already defaulted to player chose. So this means that now I can check this. So let's quickly say, let's come up the computer, let's test this out really quick and make sure that the computer got that. I'm going to say, I got the signal. Yeah, cool. So when I click one of these, hopefully the computer should say that I got the signal. And we can see that, haha, the computer did indeed get the signal. Awesome. So now, once the player has made their choice, what do we think needs to happen next, right? If we probably need to have it so that the computer actually makes its own choice. Actually, I'm gonna leave this little message here and just have it say something a little funny, like, oops. All right, let's go. Cool. So yeah, all right. So one of the things is our computer probably needs to make its decision now, right? How the player has gone. Now the computer needs to figure out like how it's going to do it. So one of the things that we have, because I can't tell the computer what to pick, right? I want the computer to make its own decision. So we have down here this pick random, right? And I can say this to 1 to 3, right? Because we have 3 choices. We have rock, paper, and scissors. So we can probably say that a number represents one of these 3 choices. The way that we're going to do that is that we're going to say pick random, and we're going to set, we should think about, well, how do we take this random number and we turn it into a choice? I'm actually going to make a new variable, and I'm going to call it random number. Cool. And then I'm going to say, come up here, and we have these control ones, right? So we have what's called in programming like conditional statements. It helps the computer make a decision based off of things that are happening, right? If we think about what we were talking about before with the 4 steps, one of them was making choices. This is one of the ways that we do that. So we have these statements up here to help us out, like, hey, if this has happened or if this thing is what's going on, then do this, right? So I'm going to say, let's say if we do a variable, we pick random, let's see, what is it that I want to use? All right, here, and then we'll say if, nope, I need to set my, first thing I need to do is probably set my random number, right, to that. So cool, so first I need to do this actually. First I need to set my random number to 1 to 3. So let's see if this happens, right? If I click on here, I should set a random number, and cool, I actually can see that I got 2 back. So I'm probably just gonna go like number 1 is like rock, number 2 is is paper and like number 3 is scissors. So I'm gonna come here and I'm gonna be like, okay, cool. So if, and I can drag this in here, random number is equal to 1, what we can do is I can drag this in here and I can say set CPU choice to rock. Otherwise, and I can do this with the conditionals, we can actually drag another one in here. If that's the case, you could just do like if statements, but if else statements allow us to make another decision if the first one doesn't pan out. So like, hey, if the number is 1, then set it to rock. Otherwise, if it's not 1, do something else. And so I'm going to go ahead and say, I'm going to duplicate this and drop this in here. I'm going to say if random number is 2, then what should we probably do? Paper, right? So come back down here, set my CPU choice to paper. And then the last thing is I don't even have to do another if statement because the only other choice that we have is number 3, which is going to be scissors. So otherwise, I'm going to say set my CPU choice to scissors. All right, cool. So now I've got all these variables up here. Let's see how this works. So if I click on rock, I set my player choice to rock. My random number is 2, and then, aha, the computer chose paper. Cool. So now that we know that the player can choose and that the CPU can choose, and I'm actually going to uncheck these to kind of move them because now that we've tested that, we've seen that it works. So now I can take those off. The player chose, the computer chose. What's left to do? Well, check the win condition, right? We need to see who won the game. And I think the computer just chose paper, so technically I would have lost. So we can do that with more conditional statements, right? So let's say if, now we can check, right? Let's check, let's pit the computer's choice versus the player's choice and like see who came out on top. And then, so we have some more of these operators down here. And the one that we want to use is, the first one is we're going to say equals, right? The first condition I probably want to check is to see, was it a tie? And the cool thing is that I can just drag what the player chose and I can drag what the CPU chose. And I can just say, hey, if it's equal, and if for that, I'm just actually going to have the computer to like kind of tell us what the condition, what happened. So I'll say, have the computer say, hey, it's a tie. It's a tie. I can put a little emoji here. Just, it's a tie, right? And it's going to say that for 2 seconds. Cool. So let me build out the rest of this because this is the part that's gonna. We don't see any paper or scissor sprites. Oh, you can't see all of this stuff over here. Let me see if I can full screen it. Can you see it now? All right. Yeah, this should all be here. Yeah, so I'm going to continue building this out really quick. Oh, on your app? Oh, so you have to go out and find a picture of scissors. So what I did was that there's a little option right here to upload a sprite. And then you can click on this and you can add your own picture. So here I've got my own pictures of a paper and scissors. So I would say just go to Google and yeah, yeah, don't worry about it. Go to Google and just look for like a picture of paper or scissors and then plop it in here. You're welcome. Yeah, so let me go ahead and continue just building out the rest of this, like checking to see who won based off of like what. So let's take it here. So if I'm going to say and if, no, I don't think I want and, right? If, let's see, actually, no, that's correct. So I'm going to say if, and let's drag this in here. And let's drag this in here. So I'm going to say, let's go start from the top. So if the player chose rock and the computer chose paper, then what we're going to say is that the player lost, right? And so I'm going to have the computer say, I chose paper, you lose. And he's gonna laugh at us. Why not? we can have the computer be as be a little gloaty, right? And actually what I can do is I can just duplicate this and just slide it in here. Right. And then I can say if the player chose rock, but the computer chose scissors, then we can have them say, I chose scissors. You won. And we can actually just have them be a crybaby. And then what I can do is I can duplicate this because I can just keep checking the conditions over and over by popping them into the L. So, hey, check if this is the case. If it's not, okay, check the next one. Okay, if it's not, check the next one, and just go through the motions of checking each of those, right? Because we have to think about every possible combination of these things that can clash with each other. So I'm going to say if the player chose paper and you chose, and the computer says, so he wins. So he's going to say, I win. I choose scissors, I win, and he's going to go back to being a little bit on the, now he's going to laugh. And let me duplicate this again. I'll slap it in here. And if you chose paper and then you choose rock, then it's going to be, I chose paper, and he's going to lose. Lose, and he's going to cry. Where's the cry face? Yeah, there we go. And then let's go here. So, and then I think what we have left is just scissors for the player, right? And then if the computer chose rock, so he's going to say, I chose rock, you chose scissors, so I won. And we're going to go back to being grinny. And then, oh, we're down to our last condition, which is the player chooses scissors and he chooses paper. So I'm just going to go ahead and duplicate this one. And since there's no other possibility, it's going to be I chose paper and I lost. He's not going to be happy about that. He's going to be crying. All right, cool. This is a lot of logic that just went into one place. But now we can check and see if it works. So let's see. All right, I'm going to click on rock and let's see what happens. All right, let's go. I chose scissors, you won. All right, cool. And again, we can even turn back on our variables just to double check and make sure that everything is happening. So we can see that we chose rock and we chose scissors and we won. So let's try it again. Let's choose rock. And they chose rock and it's a tie. Cool. Let's try paper. Uh-oh. Uh-oh, what happened there? He chose scissors, he won. Choose paper. Choose paper, it's a tie. I chose scissors, he won. Ah, stop beating me. Okay, scissors, okay. And then I'm just gonna go through all the conditions just to double check and make sure that that most all of these win for all of them. So scissors and scissors, it's a tie. Let's see, paper, it's a tie. Paper, it's a tie. No, show me the other ones. Okay, so I see that I had a problem. I chose paper and the computer chose rock, and it still says that he lost. So I made a boo-boo here, and it says, oops, I didn't change the text here. So this is why we test. I chose rock, I lose. Okay, now that makes more sense. So, and that's why we test. But there you have it. That's actually the entire game. That's an incredibly simple way to do it. But the way that I would say is, if we think about this, this kind of looks a little messy, right? And one of the things in programming is we have what's called dry, which is don't repeat yourself. And that's kind of what we did here. We made a lot of just like if then, all in one go. And typically you wouldn't want to necessarily do this. So one of the things, if you want to explore like programming more, and what I would encourage is like thinking about ways that we could maybe separate this out and maybe break it down so it's a lot simpler and easier to read for somebody. And it makes it easier to debug or find where something went wrong. But congratulations, you've just actually made paper, rock, scissors, or rock, paper, scissors. I always say it wrong. Cool. All right. Does anybody have any questions really quick?
That was great, Princeton. Thank you so much.
All right.
I think everybody enjoyed it, and feel free to stay on for a little bit and answer questions in the chat field and the Q&A. We appreciate your time. Thank you so much.
All right. Thank you for letting me be here.
Yeah, absolutely. Thank you. Hi. Have a good day. 8. Everyone. Today we get to hear from Alethea Master. She's going to talk about being an entrepreneur. So I'm going to hand it over to you, Alethea, and let me know if you need anything.
Thank you. Thank you so much, Heather. Good afternoon, everyone. It is so great to be here on Georgia STEM Day. I am thrilled to be here with you and to share a little bit about some lessons that we've learned along the way. My name is Alethea Master, and I'm the founder and CEO of Madlearn. And I'm going to share my screen real quick. So give me a little thumbs up if you can see that. Hopefully we can. Excellent. And the talk that I want to do with you today is called Be a Preneur. Anypreneur. And you're probably thinking, what does that even mean? Those aren't real words. I like making up words, and I'll tell you why. I was born in a little town called Reading, Pennsylvania. And if you've played Monopoly, you know Reading Railroad. It's not Reading Railroad, it's Reading Railroad. And I was born in this little town called Reading, Pennsylvania. And my brother and I were 2 of maybe 5 kids of color in our entire elementary school. We had about 500 kids in our elementary school, and we were 2 of maybe 5 kids of color. And so we stood out a lot. We got made fun of a lot. We got called things like burnt toast. On the playground, when I would try to be a part of the cheerleading gang, I would always be the one that felt left out. I would be excluded. It was not a fun time. It was not a fun experience. If you see someone be bullied, please stop them. Please support the person being bullied, and don't bully. It's not a good thing. I was there. Unfortunately, many of you may have been there as well. And when I was about 8 years old, my parents made the upside down decision to move from the United States halfway across the world back to India, which is where we're originally from. And we fell on the floor laughing when we heard this idea. We said, nobody does that. Everybody moves to this country. Nobody moves back to the country that they're from. And lo and behold, a few months later, we were on a plane moving to India. And I was nervous. I was so nervous, and I was so excited at the same time. I was nervous because I was leaving home. I was leaving my family and my friends. But I was also excited because I thought, when I go to school now in India, everyone will look just like me. I won't get bullied. I won't get made fun of. And that's a good thing. So when we moved to India, my brother and I, we learned 3 new languages just as soon as we got there, because different people in different parts of our world spoke different languages. So I had to learn Urdu, I had to learn Marathi, I had to learn Hindi and Gujarati. We learned all these different languages when we got there. And on my first day of school, I was so excited. I had my Trapper Keeper. I don't know if you guys use Trapper Keepers anymore, but I had all my stickers and my craft box, and I was so excited to go to school on my first day. And I thought, this will be great. Everyone looks just like me. I'll fit in. It'll be great. And guess what? I got bullied. I got made fun of because I was the girl that had a different backpack. I was the girl that spoke differently. I had a Trapper Keeper, which no one else had. And so I realized at the ripe young age of 8 years old, my first entrepreneurial lesson: you can never fit in. And that's okay. It's okay to not fit in because only you can be you. You are the only person in the world that can be you. And that is the magic and that is the power of you. In India, my classroom looked a little bit like this. There was a lot of students in each class and there was a lot of work and hard studying and hard work around every single test and exam that we had to pass and do well in. And I played sports, I played basketball, and I realized that not everyone got a medal. Not everyone got a first place prize. And it was something that we had to work really hard for. We had to compete. We had to study hard. This is my graduating class. I'm the tall one there in the back. We had so many students that we were working with and competing with. But I realized through that process and through that very different system of education, my second entrepreneurial lesson, that competition is a real thing. It is not that everyone wins all the time. When the real world, there are some companies that do better than other companies. There's some people that do better than other people. And the important thing about competition is using it to your advantage, learning from each other, learning from the people that are doing well and figuring out how you can make yourself better in one way or another. After school, I decided to move back from India all the way back here to the United States for college. And I love kids. I've always loved kids. I've always wanted to work with students or with kids in one way or another. So I thought I'm going to become a pediatrician. Unfortunately, all Indian parents will encourage their kids to be doctors or engineers. And so I thought I should become a pediatrician. And I came to Emory University here in Atlanta, Georgia. And I realized that medicine was not for me. I took a lot of classes, I liked it, but that's not what I wanted to do when I grew up. And so I took a liberal arts education. I took a lot of different classes. I tried a lot of different things. I took some psychology courses and some education courses, and I fell in love with education. I fell in love with the idea of helping our students, our bright young minds, just like you, be able to exist in a better way, learn in a better way, and be successful in life in one way or another. And I learned my third very important entrepreneurial lesson: try everything. Try everything. You never know what you're going to miss out on. You never know what you're going to like or not like until you try it. And case in point, I'm here talking to you today about how I built my very first app and how you can build an app as well. And the only way that happens is if you try something new. So speaking of trying new things, this is my husband and I, just a couple of weeks ago, we were skiing in Colorado. And the first time I tried skiing, I was horrible at it. And it took a lot of years for me to get good at it and a few broken bones, but I tried everything. When you try everything, you have new people that you meet, new experiences that you can create for yourself. When you try everything, you land yourself on the 40 under 40 list at Emory University. That's me in the bottom left corner there. And I was so honored with that award just this year. And when I was at Emory, when I was in college, I met Dr. Paharis, who is a phenomenal professor in the education department. And he talked to me about his passion around education, and he mentored me. And through him, I learned my fourth and very important entrepreneurial lesson: never underestimate the power of a mentor. A parent, a teacher, a guidance counselor, a friend, somebody in your life that you can talk to, that you can share ideas with, that they can push you and say, hey, why are you thinking this? Why aren't you thinking that way? You never know what you can learn from other people. And so find that mentor in your life, find that special person or people that you can talk to and you can brainstorm ideas with, because it can and will change how your life can be. After college, I decided to become a teacher. I knew I wanted to be involved in education, and so I decided to become a Montessori teacher. I loved Montessori and all of the different things that students do in a Montessori classroom. So I taught for many years, and I absolutely loved it. This is my first classroom, as a matter of fact. There were 6 students at a small school in Atlanta that we taught at together, and those 6 students, fast forward about 10 years, this is our 10-year get together, and they're now taller than me. So that was a little scary. Kids, please don't grow up. Stay just the way you are. No, just kidding. Become awesome. But I taught for many years and I absolutely loved it. But I also had a problem as a teacher. And my problem in the classroom was parents not knowing what was happening and why we were doing things a certain way. And so I had a problem that lots of other teachers faced, which was parent communication. And so I decided to step out of the classroom and work on starting a company. I worked on starting a startup. I was an entrepreneur, an educator turned entrepreneur, an edupreneur. And the work that I did with my first idea, the first company that I started, was us building apps for schools, building websites for schools. 10 years ago, nobody had an app on their phone for a school. Today we do. Lots of our schools, lots of our school districts have their own app, which is great. But the work that I did there landed me in Forbes magazine and shared a little bit of story about how we did that. And I realized that while we were doing really good work and we grew us from a team of 1 of us to a team of 60 of us, I was working on the communications and the operations side of education. And when you look at this wheel of impact, there's so many different ways to be involved in a school or be involved in our system of education. And I realized that my heart was not on the operational side of things, it was on the instructional side of things. I wanted to make sure that I could be in the classroom and working with students just like you and impacting our bright young minds of the future. And so I realized in this process that while the company I started was great and it was doing well, it wasn't where my heart lay. And I learned my 5th and very important entrepreneurial lesson: be brave enough to suck at something new. You never know, like I said before, you never know what can happen when you step out of your comfort zone, when you try something new. And unless you don't try something new, you will just stay in that little comfort zone, that cocoon that we all live in. And the magic happens outside of that comfort zone. So when I said, okay, this is not the company for me, this is not what I want to do, I want to try something new, I want to do something that's different and that's new, I was able to meet this phenomenal group of people that I now call my team. We have team members in India, in Ghana, all over the United States. And together we came up with a program that is called MadLearn. And this is the company that I now run. We started this about 8 years ago. And we wanted to create something that we wish existed. And what we wish existed was a program that helps students just like you create their own mobile apps. So rather than us building the apps for schools, we said students need to learn how to do this. You need to learn how to build your own app, see it on your phone. You're on your phone 24/7 for better or for worse. Let's figure out how we can create for it instead. So MAD stands for Mobile App Development, and it's a tool, it's a curriculum, it's training that we developed for schools to use to learn how to build apps. And we're based on a 6-step design thinking process where students will learn how to think of an idea, plan it, design it, build it, test it, and launch it. I know right before this talk, we were learning how to create a game about rock, paper, scissors. You could learn how to create an app in that same way as well. And that is just the power of not just consuming technology, but creating it. You know, you use the apps, now we want you to create for it. So over the last 8 years, we've had an opportunity to work with hundreds of schools, thousands of students all over the world. And here's what we've been able to make happen through that process.
I like this app. Yeah, it's gonna be awesome.
MAD stands for Mobile App Development, and MadLearn is a program that is focusing on teaching kids how to create mobile apps. There's a lot of conversation today in the education world about 21st century skills. Those skills are a really great combination of entrepreneurial thought, collaboration, the ability to look at a problem and figure out a creative way from a technology perspective of how to solve it.
Information about that library.
This is what kids are doing. They're communicating through mobile devices. They're sharing music. They're sharing images. Why not share their apps? They will be able to see that what they can create, they can share with the world.
What excites teachers and students most about MadLearn is the fact that very early on in the process, students are actually able to achieve success.
I would just retype it.
The MadLearn program includes 2 phases. Splash screen is like the cover of the book.
We believe in starting in phase one to get students interested in developing a finished product using a very easy format to do so, and then going into the coding of that later.
By valuing what kids know and building on what they know, almost like flipping it over to look at the back side of it, then they can start to understand different elements of the computer science that goes into that.
I think this is something that all kids can use. For them, it's intuitive. I've been incredibly amazed how fast they've picked it up.
I'm not really a tech programming person. I could probably figure it out, but it made it easier for me to do it, but not have any experience with programming.
I'm working on my first app, and all these ideas of everything that I've been ever wanting to do, I could just let them flow and put them into this app.
What we're doing is it's kind of going to be almost half social media and half learning. You're going to be able to make your own account. You're going to be able to post 30-second videos of you singing. And when you make your account, you can say whether you're an alto, a bass, soprano, baritone, whatever. I'm pretty excited about it.
When I watch students become engaged in trying to solve a problem, there's nothing quite like it as an educator.
From an administrator's perspective or a superintendent's perspective, when we're looking at introducing a program like MadLearn into the curriculum, you're really thinking about not what is it going to do for my students today, but what is it going to light in them that turns into a fire, that turns into a raging fire.
I love actually doing this. It's really, really fun. Maybe later in life, this might be something I want to do.
Care a lot about these kids, and I think these are skills that, math and science and all those other things, those core things, are real important to us. I see this as a way of reaching kids, and that's what we want to do in the end.
The company is really trying to make learning matter to kids and make the connection with kids and their families that would sustain learning over time and across a lifetime.
So the sixth and final entrepreneurial lesson that I want to share with you is the importance of finding a real problem that exists. And it's not just one that's a real problem. It has to be one that you're passionate about as well. You saw and heard the passion of the teachers, the students, our team members in that video. It's a real problem that exists, and I'll tell you what that problem is in a second, but it's also one that we care so deeply about, that we're passionate about in so many ways. And speaking of the problem and really looking at the importance of the problem that we're trying to solve, we're teaching students how to build apps. And that's cool. It's really cool. I promise it's cool. But the reason we're doing that is because there's so many open computing jobs available in this country alone. We have over 400,000 open jobs and not enough people to fill them. And when we talk about the STEM problem and the STEM gap that we have in our country, this is why we have Georgia STEM Day, for us to be more interested in STEM and for us to get more excited about STEM jobs and STEM careers. It's really a computing problem. 67% of open STEM jobs are in computing. So we want to figure out how we can do more of this work and be exposed and become conceptual thinkers and global collaborators and creative communicators. How can we do all of these things through exciting, interesting projects that we're all looking forward to? And I want to share with you, I am not a coder and I run a tech company. And I say that not to say that coding is not important. It is essential. It's such an important thing, but it's one piece of the pie. And there's so many other parts of technology that are also important. When we look at technology, there's product ideation, there's design, there's coding, there's testing and sales and finance and all these things that come together to make any technology. And we know that technology touches every single thing that we do in our lives. And you can be involved in technology, either with code, if that's what you're interested in, or with one of these other areas that you might be interested in as well. One of the things that we've seen in terms of that interest and building that interest amongst our students is figuring out how to create something and see it instantly on your phone. So if you want, feel free to pull out your phone, download this app called Mad Store. It's our version of the App Store. So if any adults in the room, if any students have access to their phone, pull out your phone, download Mad Store, and you can see hundreds of apps that students have created all over the world. Like this student who created, a middle school student in Georgia, last summer, she created an app about babysitting. That's her passion. That's what she does after school. She wanted to help other students be better babysitters. So she made an app that teaches you how to be a good babysitter. Or this group of students who was creating an app about refugees in Atlanta and helping them learn how to settle into a new city, a new country, and become a naturalized citizen if that's something that they were interested in. Or this student in Texas who created an app. His family has a cattle ranch. He created an app called Cattle Tracker that helps him find the cattle that had strayed or gotten lost, because that was his job on the farm. And so he wanted to help create an app that made his life a little bit easier. This is me when I was about 2 years old, reaching for the skies. Fast forward about 25 years, this is me speaking at the United Nations. And the only difference in these two pictures is how tall I am and how far my voice can go. The power of my voice and the initiatives that we spoke about at the UN, EdTech initiatives across the world, and the things that are possible when you take something that you're interested in and be a preneur. Anypreneur. If you're interested in agriculture, become an agripreneur. If you're interested in technology, become a techpreneur. If you're interested in ecology or the economy, become an ecopreneur. Whatever it is that you're interested in, take that idea, do something great with it, and give it to the world. The world needs your genius. The world needs you and the ideas that you have and the passion that you have. We need you as the future generation to help us fix and solve the problems that we're facing today. So I encourage you to think big, to take your ideas and to turn them into a real product, especially here on Georgia STEM Day. Create something you wish existed, and do that in a powerful, powerful way. Thank you so much for your time. I'm going to put my contact information up here so that you have that as well. But it's such a pleasure to be here with you today. Thank you, Heather.
Thank you so much, Alethea. What an inspiring conversation we've had today. We appreciate your time and hope you will join us again. Thank you so much.
It's my pleasure.
All right. So now we have Josh from UGA coming on to talk about the Science Combustion Challenge. Go ahead, Mr. Josh.
Hello, everyone. Thanks for having me. I appreciate you taking the time to listen to me talk about our flame challenge. So my name is Josh Tijan, and I'm an undergraduate researcher at the Rotavera Group at the University of Georgia. Also, I'm going to apologize in advance. This building is under construction right now, so if you hear any loud thumps, it's those guys trying to get the building all squared away. So hopefully, though, it's not too bad. So today I'm going to talk to you about our flame challenge, and that's geared for teachers and their students for whatever class or a small group of students to create a video that's about 1 minute to 1.5 minutes long. So why is this important, and really why should you care about combustion? So combustion doesn't just happen whenever you're camping and you're roasting hot dogs or marshmallows. Every time you're trying to get around in the world, you're probably using an internal combustion engine. Just about every car, school bus, airplane, helicopter, boat, all have internal combustion engines. And that makes it incredibly relevant to today's life. We need to understand combustion better and biofuels and their importance in those systems. So before we get too far into it, though, I'm going to show a quick video that talks a little bit about it. So hopefully I can get everything to play without any major problems. Give me 1 second. Hopefully you can see that.
Combustion provides nearly all global transportation energy. Inside an engine, a scientific orchestra unfolds in just a fraction of the time a human eye blinks, and the chemical structure of the fuel is center stage. Combustion is an exothermic chemical reaction. This means it produces heat. This heat is the energy engines use to power our transportation needs. Petroleum is used to produce hydrocarbon fuels for combustion. These fuels are composed of molecules containing hydrogen atoms and carbon atoms bonded together in different configurations. When these molecules undergo combustion at high temperatures, carbon-carbon bonds break rapidly. This means fuels break down into smaller components that lead to ignition, which produces immense heat. Advanced combustion technologies focus on lower operating temperatures, which drastically affects how combustion happens. Here, oxygen adds to the fuel, creating a new molecule, QOOH, and initiates a complex chemical sequence. This sequence involves a competition. Either the new molecule decomposes into an intermediate, such as a cyclic species, or a second oxygen molecule adds to the fuel. The balance of this competition controls reactivity. The second oxygen molecule makes the fuel very reactive. The structure of a fuel affects its reactivity. Some fuels are very reactive, whereas others are not. Biofuels usually contain oxygen in their molecular structure, which affects their combustion chemistry, particularly at low temperatures. Engine combustion at lower temperatures avoids major pollutants, such as NOx and soot. If we can understand the combustion of next-generation biofuels, including intermediates they form, we can continue to enhance energy efficiency and continue to decrease emissions. This is the focus of combustion science.
So I've got my essay written, and I've been working on it for about a week. So now I'm going to show you how I use Grammarly.
Okay, so hopefully you can see that the flyer that I've got pulled up, and I'm going to go ahead and put the link for this in the chat so that you'll have access to it, because it is very important for you to be able to get access to this in order to do the Flame Challenge. So in order to get the ball rolling, you'll go ahead and first start out by watching the videos that we have posted on our flyer. So the first of which is the one that we just watched. So if you get access to the flyer and click on this link, it will take you to the Rotavera Group's YouTube channel. Then once you get a chance to do that, watch the other videos that we're going to have posted shortly. So the second video should be out in a few days, and then the rest of them are in the pipeline to come out shortly thereafter. But if you subscribe to the channel, you should be able to get notifications whenever they actually come up. So once you've gone ahead and watched those, you'll be able to come up with a few questions and reach out to Dr. Rotavera to make sure that the topic is okay for you to start making your movie. Once you have your topics approved and you've gotten any mentorship or guidance from Dr. Rotavera, you can go ahead and start making that. We have access to the Doodly software for you to use. You just have to reach out to Dr. Rotavera in order to be able to use it. And if you want to, you can use any other software that you'd like to make the movie. It doesn't have to be Doodly, but if you'd like to, we have it for you to use. Once you've gone ahead and made your video, you can submit it up to any point in time until the 30th of November. That is the deadline, so the 30th of November. Once you submit your video and everything's great, you'll just wait until December whenever we announce the winners. So what's really exciting is that the winners for this challenge have the opportunity to win up to $1,000 for their classroom. So first place awards go for $1,000, second place is $500, third place is $400, fourth place is $250, and fifth place is $100. And the money is to be used at the discretion of the teacher who's in charge of the group for that class. So if they want to have a really fun pizza party, that's awesome. If they want to go ahead and buy some piece of equipment that they'd like to enhance the learning of their students, that is also great too. And also what is even more exciting is that we plan on doing this from this year on until 2025. So if something happens, you don't win this time around, you have the chance to win a few more times. That should be everything that needs to be covered for our Flame Challenge. Again, to get anything, any kind of help that you'll need to reach out to Dr. Rotavera, whose email address is here at the bottom of the flyer. It's Rotavera uga.edu. Also, if you can't find his email address or the flyer, you can Google UGA, Dr. Rodavera, and the Rodavera group, and his email address should pop up. So that shouldn't be too bad whenever you're trying to reach out to him. So if anyone has any questions, I'll be hanging out for a couple more minutes. But if not, thanks a lot. Thanks for taking the time to listen to me introduce our Flame Challenge and talk a little bit about combustion.
Thank you so much, Josh. I can't wait to see what you guys end up getting,
Yeah.
So keep me updated, all right?
Will do. Thanks a lot. We're really excited to see what you guys come up with.
I'm excited too. All right, everyone. We are now going to do intro to game design with Victoria. All right, there you go. I'm going to hand it on over to you. Thank you so much for your time today.
All right, thank you. So let's see, I'll go ahead and share my screen and we can get started. There we go. So this is game development, what it involves, and how to start. So my name's Victoria. I'm a technical artist. I've worked both as a technical artist and programmer in commercial games, apps, film, and TV shows. I'm a SCAD Atlanta graduate, a member of the Georgia Game Developers Association, as well as the International Game Developers Association, and a game development private instructor. So I have a few images down here at the bottom. Like I went to SCAD, then worked at Ninja Multimedia, which used to be a AR and VR development studio here in Atlanta. Then I went to Happy Mushroom, worked as a technical artist there, working on mainly film and TV. They're known for doing the environment work for The Mandalorian and Boba Fett series that recently came out. And starting next week, I'll be going to a different studio where I'll be working on an MMORPG, but haven't said that yet. And yeah, here's the two associations I'm part of, the Georgia Game Development Association and the International Game Development Association. So today I'm here representing GGDA, which, like I mentioned, Georgia Game Developers Association. It's a professional association for developers in Georgia. Most things they host are for professionals, are for adults 18 and over, but the one thing they do have that is open to students is the annual game college fair for high school students. You can find information about that on their website. All right, let's get started. So first I want to go over what does game development actually involve, because sometimes people don't actually know what everything that goes into a game. Because when people think of game development, they often think of programmers, right? And I have this screenshot here that's actually from Ready Player One, because if you've ever read that book or seen the movie, you'll realize there's a lot of scenes in it where they go like, wow, this guy, James Halliday, he coded all of the textures and he wrote the code for the 3D models and he wrote the code for all these things that aren't actually done through code when we're making games. Sure, the code builds the software to make things like textures and 3D models, but there's a ton of other roles involved in this. So yes, there are programmers, but there's also other things. We have programmers, you have art going into games, you have game design, you have a ton of other areas like data science and production and writing, quality assurance, audio, games have sound. And then a lot of these can be split up into even smaller disciplines where there's just tons and tons of different roles that go into game development. We can kind of go on for about these forever, but working in games is probably just about as broad as saying you work in a hospital. Working in a hospital doesn't mean you're a brain surgeon because there's a ton of different things going on there. Game development is the exact same way. So yeah, tons and tons of variety. But if you want to learn more about specific roles in games, then I suggest Riot Games' YouTube series, So You Want to Make Games, where they go over a few common roles. You can also check out the GDC YouTube channel where you can see different talks coming from different roles. It's mainly meant for professionals, but just watching it as a high school student, you can kind of get a good idea of what people do and what goes into games. All right, so then what do game developers actually work on? And most people are like, yeah, that's pretty obvious. Game developers work on video games, right? It's everything you see on Steam. But also then there's a lot of other stuff on top of that. So I would say probably 90% of developers, I'm just guessing here, but if not more, have worked on something other than specifically video games. And that's because the skills used to make games can also apply to a lot of other fields, specifically what we use game engines for, which is what games are built in. So we have mixed reality applications. This is what I used to do. So you have things like military simulation games, AR apps for corporate purposes. You have tabletop games. People forget about that, but that still involves game designers, still involves 2D artists, sometimes 3D artists. Virtual production, which is using, or at least now it means using game engines up on LED screens to apply to film and using that as backgrounds to help reduce cost and make film production a little more efficient. You've got architectural visualization as well as automotive visualization. And then of course, mobile games, which are still video games people often forget, like, oh yeah, this is another thing that it's made. It's not just what's on Steam. Live events. Here I have two pictures of a recent League event where I believe this was a say like virtual space for people to watch an event during COVID. And then you also have things like projection work that is often done in game engines by people who are normally game developers. And then of course, interactive installations, because again, you're working with something that's digital, runs in real time and is interactive. So you often end up with game developers working on those too. And now what a lot of people want to know is, okay, so I really like playing games, or I really want to get into making them. How do I actually start? And that can be kind of a huge black box, or you just Google it and there's just a ton of different directions that it sends you in. So first say there are a lot of relevant high school subjects here. A lot of times you hear people say like, oh yeah, I had to learn algebra in high school, or I had to learn calculus. When am I ever actually going to use that in my job? Who uses that? And the answer is I do, and a lot of other people who work in game development. So it's like a few of the most important areas here that may be covered in high school. So trigonometry, for sure. You can think of game engines as just they draw triangles really fast. You have a lot of problems that involve trigonometry as well as algebra. Probably our most important one is linear algebra. Also, things involve calculus 1 and 2, mainly because game engines work with a lot of physics, right? You've got to get games to accurately simulate what happens in the real world. And then statistics, both for things like profiling, which is trying to figure out the frame rate a game's running at and optimizing it so it can run at a good frame rate. And then also all the data and analytics that go into collecting information about players, figuring out game balance, iterating on the game based off the data come in from players. Physics, like I mentioned, very important in games. And then of course, art. You have traditional art, which feeds into digital art, and digital art, super important in games. And then of course, the obvious one, computer science. All right. So there's two approaches to learning games. You have your 4-year degree for game development, plus learning, plus being self-taught, because honestly, I don't think 4 years is enough to get anyone to a professional level in game development most of the time. Most students have to put in a lot of time on their own as well, or you can be self-taught exclusively. So the advantage of a 4-year degree, of course, being that it's faster or more expensive. If you're interested, like I mentioned, you can check out the GGDA Game College Fair. And then with tech roles, you're normally going into a computer science degree or a computer science focused game degree. And then for art roles, you're usually looking at a 3D production art degree or an art focused games degree. For this, if you're interested in art schools for games, I'd check out what's called the Rookies, which is a digital art competition for people who are amateurs, or not necessarily amateurs, have been working in industry for less than a year. And every year they go through all the contestants and they rank schools based off how the artists at those schools did. So their rankings are pretty good for game art schools. And then for game design, again, games degree, or you're looking at somewhat probably a CS focused game degree, because you never want to learn just how to design games to be employable. You want to learn how to implement things and actually come up with prototypes to show your designs by yourself, because a lot of times no matter how many designs you come up with, it's going to be hard to find someone who just wants to implement them for you. They probably have their own ideas. Or you could be self-taught exclusively, which is generally slower, but it's also cheaper and equally as viable. I know a lot of self-taught game developers. But the important thing here is you can start right now. You don't have to wait until you're in college to start developing games. There are games out there on Steam that have been fully developed, published, put on Steam by people under 18. So we're going to start with where to start learning if you're either interested in just hopping into game development right now, or if you want to prepare a portfolio to apply to game development schools. I'm also going to, this is using, I'd say, the real deal programs. By the time you're in high school, I'd say you're fully capable of using the same professional software that people are going to use to actually make games. And the great thing is a lot of it is free. So the first place to start would be game jams, which are different events where you have a certain time period, you get into teams and you make a game in that time period. The most common frame is 48 hours, which is super fast, but they're a ton of fun. Most famous one is Global Game Jam, which actually there's a few sites hosted in Georgia at different college campuses where you'll go in, form a team, pick a role. Maybe you're working on the art for a game, or you're working as a programmer, or you're just working on audio or writing. And then your team's in charge of putting together a game in 48 hours. I will say Global Game Jam is 18 and up unless you're accompanied by your guardian. So if you're under 18 and can get a parent to go with you, then that's great. There's also online game jams that you can find through itch.io. And a lot of those, because you're not going on a campus and staying there overnight, you don't have that restriction. All right. And then the game engine. This is the one I suggest and teach. It's Unreal Engine, which I will escape this real quick and go to the site. So this is the same game engine that's used to create games like Fortnite. And the great thing is it's completely free to use, and it has a lot of stuff to just start learning it. So you can go to their site, unrealengine.com, and up at the top, you'll see this learning tab. And if you just go to all learning or online courses, there's a ton of free courses here that just help you start making games or working on architectural visualization or virtual production or whatever you want to do. And also really extensive documentation. It's pretty friendly to just jump into. Let's go back to this presentation here. Okay. But if you want something a little more specific, I can recommend a few things for different roles. So if you want to get into programming, I didn't get computer science in high school. I think you all might now. But if you don't, there's Harvard CS50, which you can go through edX. It's a free online course and really easy to follow intro computer science course. I know a lot of people go, oh wait, it's Harvard, it's gonna be difficult. No, this is a class meant for majors and non-majors, and it's introductory, like a 100 level class. It's really approachable, easy to go through, a lot of fun to take too. Like I mentioned, you can go to Unreal Engine Learning. If you're trying to get into programming, the first one I would suggest that is looking at the learning path they have called Exploring Blueprints, which is their visual scripting system. There's a few different YouTube channels I would suggest for learning game development, including Dev Addict, Make Games with Katie, and Game Dev Academy. These all have a lot of beginner-friendly tutorials. If you're looking at becoming a programmer and working in games, your two most important languages are going to be C# and C++. For Unreal Engine, you're going to be working in C++. So once you have kind of the basic understanding of computer science, I would suggest learncpp.com. And that's just a huge tutorial series on how to start learning C++. And then, like I mentioned, of course, Global Game Jam. All right. For 3D artists, there's fewer free resources out here, especially because most of the software here is not all of it's super expensive, but it's not free, and I'm only suggesting free things here. But Blender is a free 3D modeling program that is used to not be, I'd say, professionally applicable, but nowadays I'm saying like roughly 20–30% of professional artists use Blender primarily as their main 3D modeling program. And there's a very famous donut tutorial out there that you can look at, as well as this channel of CG Cookie that offers an introductory Intro to Blender, of course. And then with the Unreal Engine Learning tab, the 2 learning paths I would suggest would be becoming an environment artist overview, and then building a detective's office game environment, which just walks you through the process of building a somewhat professional, kind of polished game environment. And then, of course, for everyone, Global Game Jam and other game jams. And then for designers, a lot of what you're going to be looking at first is going to be text-based. Here's a few different book recommendations. I'd say the Art of Game Design Book of Lenses is the easiest to start with. There's also a class on Masterclass done by Will Wright on game mechanics. It's kind of a nice introduction to designing games and it's $15. So look at that. And then in terms of actually building prototypes, same suggestion as programmers, going to Unreal Engine Learning and looking at the Exploring Blueprints path. edX also has a few history of game design classes you can take for free. And then again, Global Game Jam, right? And questions, yeah, I wanted to make sure we left plenty of time for questions here because I just went over a lot of information and want to see what people have to say. So figure out how I'm going to stop sharing quickly and go back to the chat. All right. I actually don't see any questions, possibly, unless I'm looking at the wrong section. Where was I born? I was born in South Carolina. So you all are actually kind of lucky. I had to go out of state to study game development because it's not offered in South Carolina at all, but it's in Georgia. You have quite a few options in terms of colleges to pick from, game development studios that are based here, internships that actually occur around here. So it's nice. Okay. Let's see. Oh, okay, wait. Now I see the questions. There's a different tab in the regular chat. All right. So someone says, have you worked with Epic? Not for them, with them. They offer some pretty good support for developers where if you are a company working in Unreal, then they'll meet with you and help your company out and offer you support. Okay, what do I do? So I'm a technical artist, which you can think of as a halfway point between a CG artist and a programmer. They're kind of, technical artists are meant to be kind of the bridge between the two disciplines. Yeah.
Victoria, at what age did you get interested in game development?
So I'd say probably around 15, 16 is when I'll admit it started with Dungeons and Dragons and trying to build homebrew things for that. Going through the game design books I mentioned, trying to learn how that could be applicable to playing D&D, and then kind of moved from there to actually studying game development more formally when I was probably 17, 18.
You're being asked how old you are. I don't know if you want to answer that. But.
Okay, yeah. So I'm 21. I did skip a few grades, so that's, yeah, I could ask that a lot.
Well, you've done a lot in your short time, right? So must be rather advanced. So have you been a part of any of the gaming conferences, or are there any things that you would like to just share upon the industry itself?
Yeah, so in terms of gaming conferences, there's one I like to volunteer for every year, Siege, hosted by GGDA, and that's kind of our local game development convention. The other one I've volunteered for in the past is called ECGC, and that one's in North Carolina. If anyone's interested in traveling, that one's actually a very student-focused and student-friendly convention. The other one is last year I was part of the IGDA Atlanta board, and we hosted our own online game development conference as a sort of 2-day event. That was a lot of fun to host.
Very nice. And I think Atlanta has their own gaming team, correct?
Atlanta's gaming team?
Yep. They have their own team. Since it's gone or has grown, I guess, if you want to say, in popularity, Atlanta has their own team.
Oh, you mean as
for
in
gaming.
esports?
Esports.
Yeah, okay. So esports is something I'm not too familiar with. I'm more on the development side, but I'm pretty sure some of the universities around here do.
Oh, absolutely, absolutely. Now they are asking if you've played Fortnite.
So I have not played Fortnite. I played PUBG instead. I'm not very good at it, but I did play PUBG for a bit there back when it was a little more popular. All right. Let's see. I guess I can, if we don't have many questions, I can go a bit into these learning paths a bit more if you're interested.
That would be great.
Let me go back to sharing my screen here. Okay. So like I mentioned, the thing I suggest is going into Unreal Engine Learning, which if we go back to this tab, I go to the All Learning category. They do have some things that are instructor led, but a lot of it is what you're going to access through this learning portal here. I'm gonna stop sharing so I can log in actually. Pause share, here we go. Okay. And this is what the learning portal looks like. So here on the content library tab, you can just see all of the courses they have available. So like I mentioned, there's the Welcome to Architectural Visualization or Game Development or Film and Television. Doing a lot of other niche topics as well, like animation for virtual production or procedural sound design. And you can filter over things. What I like to do is just filter by learning paths at first, because that will give you some of the more high level, broad reaching paths, as well as going to courses, which will give you some more specific things, like I want to do advanced skills for environment art. Let's see. The YouTube series I suggested, I'd say the one that is most friendly here to beginners is going to be Make Games with Katie. That's a pretty new channel, but if you ever want a really, really thorough introduction to blueprints, you can get that there. These other two here are going to be a little quicker, and but they're going to kind of get you into here's the game, we're going to make this the next 7 hours, go walk you through the whole thing. And what happens is, for most people when they start learning, is you first go through different tutorials following games other people have made and you recreate them. And then from that, you eventually piece together, oh, these are how these systems work together. These are the types of components and pieces and types of functionality that go into something, and then use that to, I guess, extract it and then go into making your own games. So I'd say it'd be great if possible to kind of maybe go through one of these series or go through some of the learning material before jumping into a game jam. If you are interested in Global Game Jam specifically, that one happens in January, but you also have a few other big game jams scattered throughout the year, like the one I'm thinking of, the Game Makers Toolkit Game Jam. I'm not sure when that happens, but I do believe it hasn't happened this year yet. Questions. Will you come and visit my school? Potentially. I don't know where it is. Okay. Okay. Let's see. So I think as an example, in the learning portal, we'll go ahead and pull up the environment art course I mentioned, which I think is a pretty good place to start. And the detective office one. Yep, here it is. So if sent a few people I've instructed to this course specifically because it does go through a lot of different things and provide you with the assets, so you don't actually have to know any 3D modeling going into this. But what it does is you end up making this environment here, something similar to it, with kind of assets provided already to you. And to install, you all may be familiar with this already, but to install Unreal Engine and kind of start looking through what's available there, that's going to be through the Epic Games Launcher, which of course a lot of people know it as something you play games on and buy games on. But if you look in the bottom left corner here, you're going to go to the Unreal Engine tab, and that's where you're going to download your engine versions. That's when you're going to learn a lot of things, or like they feature specific projects. And they also have free 3D models and whatnot that you can get every month. There's this free for the month category that's always fun, where you can start downloading assets, plugins, playing with them, building games out of them. They're fun to use. Yeah. Okay. Let's see, are there any other questions?
Thank you, Victoria. I don't see questions at the moment, but if you don't mind staying on for a little bit longer, we have had individuals ask questions in the chat field or in the Q&A field. So much appreciative of everything you've done today. Thank you for showing what you do for a living, and very excited to see that you have skipped grades and have been in the game development for a number of times. So thank you, Victoria. Have a wonderful day. Happy STEAM Day.
Yeah, thank you so much.
All right. So now we would like to pull up Jordan Rose and Robert Simmons, where we will have an exciting discussion on STEM equity with Science ATL. Hello, gentlemen. I'm going to pass it over to you now. Thank you so much.
Excellent. Hello, hello. Happy STEM Day. How you doing, Robert?
Doing well, sir. How's it going?
It's going well. It's going well.
I hear you.
Oh, hey, I see some friends in the chat. Hello to you. If you're gonna make a comment in the chat, make sure that you select everyone so that we can all see it. I'm really happy to be here. My name is Jordan Rose. I'm the executive co-director of Science ATL. I'm really happy to be here with my new friend, Robert Simmons from the Micron Foundation. I'll give him a proper introduction in a minute here. Georgia STEM Day, amazing programming going on for students and for educators. And this next period, we're going to talk about hip hop, STEM, and social justice. And before I introduce Robert, I just wanted to say a little bit about Science ATL, my organization. We are a nonprofit in Metro Atlanta. We are creating and cultivating a community, an equitable community of science lovers in Metro Atlanta. And we do that by hosting public events like the upcoming Atlanta Science Festival. And you got to wait for it here. Give me 1 second here. There's gonna be a big splash. You're gonna see it in any minute now. There it is. There it is, Atlanta Science Festival. Bam. It's 100 events that happen all over Metro Atlanta for curious kids and adults. And it's happening March 12 through 26, just around the corner. So March is STEM and STEAM month in Georgia. And right now we're happy to celebrate Georgia STEM Day with all of you. And I am honored to be here today with Robert Simmons. Dr. Robert Simmons is the head of social impact for Micron Technology and the Micron Foundation. As a noted scholar on education and race, Robert is currently a scholar in residence and a scholar of anti-racist praxis at American University, where he conducts research and teaches courses on race and racism in society and schools. As a member of the Diversity Scholars Network at the National Center for Institutional Diversity at the University of Michigan, Robert's research for the last 15 years has focused on racial equity in STEM and the lived realities of historically marginalized communities across multiple K-12 contexts. He's authored over 50 publications focusing on race and racial justice, as well as equity, diversity, and inclusion. And his next book, Interrupting the School to Prison Pipeline, African American Males as Critical Scholars and Intellectuals, is part of an autobiographical reflecting on his father's incarceration, while offering insights into the educational experiences of African American males. And before all that, Robert was an award-winning middle school science teacher in the Detroit Public Schools. And as a fellow with the Woodrow Wilson Fellowship Foundation and the Fulbright Memorial Fund, he traveled to Costa Rica and Japan to study educational systems and conduct environmental research in the rainforest. And now he's here with us today. Robert, I'm so pleased to welcome you. Thanks for being here with us.
Listen, man, like anytime I get to talk science, which was my first love, I'm always excited, in particular to essentially be home in Georgia. I was born at Crawford Long. It is not called Crawford Long anymore, but for those that are historians of Atlanta, they'll appreciate that I was born at Crawford Long, and we'll talk a little bit about that. I'll share my screen here for a few minutes because I really want this to be conversational. And part of what I want to talk about, Jordan, you can see my screen, right? Just want to make sure. Cool. Part of what I want to talk about as someone who believes in equity, I also have enabled closed captioning for this presentation. Because I think it's important that, as I always say to folks, brilliance and intellect is distributed equally across our human family, but opportunity and access is not. So anything I can do to ensure that everyone has access based on the particular gifts that you bring to the spot, I want to make sure that I do that. Any questions, feel free to put in the chat. Definitely want to make sure that I can respond. I'm not only here as someone who's a representative of Micron Technology and Micron Foundation, but as someone who believes in the power of STEM and science, and someone who knows that STEM and science education saved my life. It changed my career trajectory. But I'm also here as someone who's a hip hop head, someone who was raised on hip hop. When we start to think about Paid in Full by Eric B. and Rakim, the sweet steps of Kid and Play, and the amazing lyrics of Salt and Pepper, Remy Ma, and others, I'm a hip hop head. As a result of being a hip hop head, I also have been raised as a social justice advocate, but also as someone who believes in the power of STEM, not just STEM for the sake of doing it, but as an instrument and a tool for empowering young people and communities. Why Micron? Well, in November, December 2021, Micron made an announcement that we are going to open a R&D center in Atlanta to generate 500 jobs. This is super important because there are deep partnerships that we're in with various community organizations in Atlanta. We are, for the first time, one of the sponsors at the Atlanta Science Festival. So I'm excited to do that. We also host something called Chip Camp. And I'm excited to announce here for the first time publicly that Chip Camp is actually going to take place in Atlanta this year. Right. And we're working on with some community organizations on the West End and Southwest Atlanta as to where that's going to happen. But Micron is committed. But more importantly, as someone who has Atlanta running through my blood and through my veins, I'm committed to making sure that Micron is a good corporate partner and that folks in Atlanta always have access to me, always have access to resources that Micron has. I want to give you a little bit of background on the Micron Foundation.
Hi, I'm Dee Mooney, Executive Director of the Micron Foundation. Micron firmly believes in delivering equitable opportunities for all. That's why we invest in the communities where we live, work, learn, and play. I'm proud of the ways we made a global impact this year through our philanthropy, programs, and people. With $13 million distributed to charities and schools, we leaned into new ways of responding thoughtfully and compassionately to the needs of our communities around the world. And we couldn't do it without Micron's team members. More than 27,000 employees donated funds or volunteered their time in 2021. That's 60% of our global team members, a new participation record for the company. And our team members are already planning ways to do even more in 2022. Learn more. Hi, I'm.
So as I think about where Micron is and the work that we're doing and the partnerships that we're hoping to build with the Atlanta community, I also want to point you to this amazing opportunity with my colleagues in Asia to learn about the experiences of Asian women in STEM careers in that particular part of the world. I think it's important that we all celebrate International Women's Day on March 8th. So I want to just share this as an opportunity. It is based on Asian time, so it'll probably be late or early in the morning, depending on where you're at in the country. But I think it's important to understand that we all must work in solidarity with each other across the world as we think about issues of equity in STEM. So my journey into this space, in particular in Atlanta, starts at Morehouse and Spelman, where my parents were students at Morehouse and Spelman in the late 60s through the mid 70s. And as a result of that, as you can see on the left, is Crawford Long, right? And so this is a historic picture of Crawford Long from the 70s, and it certainly looks different. It has Emory across the top now, apparently. So I was kind of puzzling through that, Jordan, when I was in Atlanta last week. Like, yeah, this is a little different. And so, but nonetheless, it still has the history associated with it. So for me, the work that I'm hoping that we can accomplish together, that we will partner with many organizations across Atlanta on, is deeply rooted in the personal for me. It's deeply rooted in the personal from my parents' experiences at Morehouse and Spelman, but also the deep ways that I understand having been born in Atlanta, raised in Detroit, and the ways in which those two cities are so deeply connected. You can't meet someone, in particular in the African-American community in Detroit, who doesn't have a relative in Atlanta, and vice versa. It's just very common because we understand the nature of the Black migration to the North to work in manufacturing, and now you're starting to see reverse migration. I'm from a place where being home when the street lights came on meant just that. The smell of salt pork, over easy eggs, and grits and butter with sugar started my day. Sharecroppers in Tennessee, factory workers in Detroit, a Spelman-educated mother, and a Morehouse-educated father who was incarcerated the majority of my life. A neighborhood in Detroit where crack cocaine was common, a place where 8 Mile Road is more than a movie by Eminem, but the dividing line between city and suburbs. I am from a place where I hated high school and struggled to maintain a 2.0 prior to my junior year. A place where being the son of a librarian nurtured my love of books, metaphors, and hip hop. I am from a place where I was only the second African-American man to become a tenured professor at Loyola University, Maryland. A place where being a father changed my life and worldview. A loving grandmother, a loving mother. I am Robert Simmons. I start with this because as we think about the ways in which young folks experience the world and the justice conditions that so many of them must navigate, and we think about the origins of hip hop as being a form of social protest, it's critical to understand that when we look at hip hop and we think about all of the beautiful pieces of hip hop music and culture. And as we think about what STEM means, without STEM, you don't have hip hop. And it's important to understand the backstory of how hip hop came into being and the amazing beats that exist, the drum machines, all of the equipment that goes into it, the ways in which artists string language together. It's part art, it's part science. And so as I think about my journey as someone who's a hip hop head, a book nerd, a believer in STEM, a sneakerhead, but also as someone who was raised with deep convictions around social justice and equity in our society, I go to Brother Talib Kweli, where he said that life is a beautiful struggle. It's with this framing when I think about my journey, both professionally in STEM fields as a teacher, as a professor, as a nonprofit leader, and now as the head of social impact at Micron, that I want to challenge all of us to step into our work in STEM and science education, understanding that this work is about the struggle for young people across various zip codes to have access to quality content, but also acknowledging that brilliance, intellect, and smarts is distributed equally across our human family, but opportunity and access is not. From about 1985 to 2006, I experienced a mental incarceration while my father was physically incarcerated. Over the course of time, I realized that I needed an outlet. I needed a way to navigate my own emotions as I dealt with his absence. Where did I go? I turned to hip hop, I turned to STEM, and I turned to social justice. How did I get there? Well, I got there through books. This is a first edition signed copy to my father when he was a student at Morehouse at box 616, signed by Coretta Scott King. My father by no means was a dummy. He made mistakes. He is a flawed human being. I am my father's son, but I am also my mother's child, who gave me this great love of books, who allowed me to explore my passion for STEM and allowed me to explore my love of social justice. And how did this all start? It all started when my mother gave me an Atari game system, right? For those that are old enough to remember Atari, and you played Pac-Man and then the joystick wouldn't work. Then you had the evolution and you had ColecoVision and all these other things. And I always tell my son, yes, your PS5 or whatever heck the number it is that y'all have nowadays is nice, but it doesn't compare to playing Pac-Man on an Atari 2600 and hearing the sound of doink, 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 right? And so for me, as I began to explore this whole Atari thing, I vividly remember trying to take my Atari apart and trying to figure out, like, how does this thing actually work? Of course, my friends, they thought I was crazy because I couldn't play my video game for a while because my Atari video game system didn't work. Then came along these tall tower speakers, and my uncle gave me my own stereo system. This stereo system had a turntable. And this was in the 80s at the height of JJ Fad is Here to Rock, EPMD, You Gots to Chill, Salt and Pepper and You Gots to Push It, but also the dope sounds and lyrics of Eric B. and Rakim. It's paid in full. And when I think about all of these elements in my life of hip hop and STEM, this is what allowed me to exist in a part of Detroit that was a couple of miles from the uprising where the city burned in the 60s. A place that, if you look at analysis of crime, had a higher crime rate in my neighborhood and in my zip code than the other parts of the city. But there was always a commitment to the justice conditions of young people, the justice conditions of Detroit, but there was also this attachment to STEM and hip hop. And as I think about where we are in society now, and I think about the things that young people need, I think about the lessons that I learned and the things that I pulled from all of my time in the classroom. And the 2 times that I was nominated for National Teacher of the Year, it wasn't about the nominations for me. It was about, what does this story say about those young people on the east side of Detroit that people have forgotten? Some people question their sheer humanity and right to exist in an academic institution. What does it say about the type of education I can deliver to this group of young people by being nominated to this award? The award is not about me. It's not about self. Because anytime we turn inward and we think about STEM, in particular at the intersection of social justice, it's not about self. So as we think about what Talib Kweli articulated when we say life is a beautiful struggle, there are these 5 elements of hip hop that I want to take us to, that are reminders of ways in which we can engage young people. But these were also things that allowed me to escape. I thought that I was #1 a DJ. I had my turntable. I tore up so many albums on my turntable trying to figure out the beats. So my first STEM experiment, aside from taking things apart, was trying to be a DJ and understand why I couldn't get it to work. Well, that was because I needed a mixer. I thought I could just have a turntable and it would do all these things. But at that point, Kid Capri, for those that understand hip hop legacy, Kid Capri was the premier DJ. And I'm like, I don't sound like Kid Capri because I need a mixer, right? And I didn't have Kid Capri's artistic ability to utilize beats to tell a story. Then I dabbled in this whole thing of wanting to be an MC, and I was terrible at it. But I was certainly good at repeating back lyrics of my favorite artists of the day. Repeating back the words of Biggie when he said stereotypes of a black male is misunderstood and it's still all good. Thinking about the words of Kid and Play, of Ola, 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 A. It rung true to me that I would never be an MC, but I could certainly understand the elements of thinking about graffiti. And understanding that when we think about graffiti as a form of literacy and as a form of protest for so many young folks, we understand the art and the writing that goes with graffiti. Now, I'm certainly not advocating for the destruction of property with graffiti. What I'm talking about is the artistic endeavor of graffiti and how young people use graffiti as a form of literacy. One of the greatest scholars on graffiti in our communities is a University of Michigan professor, Elizabeth Moji. She talks about literacy and graffiti, not just about teaching young people about how to read, but getting them to utilize graffiti to think about the world. As I think about b-boying and the art known as breakdancing, I was the worst breakdancer in the world. I had my cardboard. I tried to spin. I had the shoes. I had on red Levi's and a belt buckle. I thought I was ready. But I could not figure out the whole breakdancing thing, right? And heaven knows if I actually tried to show a young person now how to break dance, I would not get up at close to 50 years old. The final element of hip hop that I want to bring to you that speaks to me and has always spoken to me as someone who's a book nerd and as someone who's a reader and as someone who's a writer is the centrality of hip hop and STEM and social justice, where they all intersect with knowledge. In order to understand STEM, you need knowledge, and it shouldn't be knowledge that's accessible to the privileged and the few. It should be knowledge that's accessible to the masses. Hip hop was a tool and an instrument going back to its inception in New York City that brought music to the masses. Chuck D once said that hip hop is the CNN of the masses. Hip hop has the ability to convey knowledge. It conveyed knowledge to me. when I think about Boogie Down Productions and My Philosophy, as I think about the words Right Now of Kendrick Lamar, as I think about some of the amazing work that comes out of so many amazing MCs, it leads me to these 4 buckets when I think about lessons that I've learned that allowed me to escape from the struggle that I had as a young person, where I almost got kicked out of high school, where I struggled with my grades. And what I learned from these 5 elements of hip hop that I would encourage you to convey and work with young folks on and in our communities is number 1, write about it. Hip hop allowed me a form of expression. It allowed me to really engage with the written word. As someone who's a strong believer in the utilization of hip hop to articulate a particular perspective, we can turn to the words of so many artists, of so many spoken word artists, where people have conveyed their thoughts and words in writing. Hip hop challenged me to talk about it. It challenged me to think about the ways in which you can lyrically articulate your point about the justice conditions in your community, but also utilize language to convey a complex topic in STEM to young people. These 5 elements of hip hop encourage me to think about it, encourage me to be a thinker about the world. All of the great STEM leaders of our time are thinkers. They're writers. They talk about it. But the last thing that all of them have in common is that they get really creative with it. And I'll never forget the first time that I realized that the inventor of the Super Soaker was an African-American man. I thought I was gonna lose my mind. I was like, yo, this is the business. I had no idea of that. But when I found out, I tried everything I could to take my Super Soaker apart. I tried everything I could to put it back together. So that we can get to some conversation, I just want to leave you with these 5 lessons that I've drawn over the course of my time as a classroom teacher. And I still teach at the university and still conduct research. But these are some lessons that I learned and I've drawn from the 5 elements that I've mentioned that I always bring into, not just into my K-12 teaching, but my university teaching as a professor at American University. Get on the microphone is your lesson number 1 as an educator. What does it mean to co-teach with young people in a STEM classroom? To allow them to co-construct knowledge, share the mic, and most importantly, share the power. That's what we're really doing social justice work. It's about power sharing. The visual, which attached to the graffiti. What is our ability in STEM classrooms to use visual representations of complex concepts? What does that actually look like? And how do we do it? Student movement. How do we allow young people to move in classrooms, especially as we think about what's happened over the last 2 years with young people? And this is where we get to breakdancing. And by no stretch of imagination am I encourage anybody to breakdance in a STEM classroom, because I don't know if you'd be able to get back up, because I certainly wouldn't. But what I am suggesting is that there's a need for student movement when we think about STEM education and what happens in classrooms. Music, as an educator, allow your students to be a DJ. And I always tell folks, if you want to really understand your students, you can learn a lot about them through music. Now, I'm not suggesting that all the music they listen to is actually real hip hop, right? And we can debate that, right? However, you learn about what they like. You learn about how they define hip hop. You learn about all of the things that make meaning for them. And the last thing I'll say is this. The great Gloria Ladson-Billings once said that culturally relevant pedagogy isn't a niche. It's good teaching. And as we think about STEM, when I walked away at the end of my career where I'm no longer teaching, I have no idea when that will be. How do we leverage your STEM pedagogy to ensure that young people increase and enhance their knowledge of self, and that they can reflect on the relevant social issues of our time. When we do that, STEM becomes the domain of the many, not just the few. It allows a kid like me from Atlanta, grew up in Detroit, who experienced the incarceration of my father, but was loved by my mother and my grandmother through books, through grits and country ham. It allows a kid like me to go on to impact the world in a very different way. It allows a kid like me to walk through the rainforest of Costa Rica, wander the hills of Machu Picchu, and wander into a club in Tokyo, Japan, and hear Jay-Z pumping like I was in Brooklyn. This whole STEM thing has taken me on a journey. It saved my life. It gave me hope and filled me with opportunities that I don't think I could imagine growing up in 48210, my zip code in Detroit. Thank y'all so much. I appreciate the time.
Robert, thank you. Thank you, sir. I really appreciate you sharing your story with us.
Sure.
About your growth and experiences as a young man, and what that means to you, and how you impart that to educators who are influencing our young people.
Yeah.
Yeah. I mean, I love your elements.
Thank you so much.
I like taking screenshots over here, right? So I want to ask you, one of the elements that I loved was knowledge, and how STEM makes how hip hop and STEM can both make knowledge real and distributed through the masses. So like what are some ways that what are some examples that you've seen of the integration of STEM and social justice issues through, that educators are using in the classroom?
Yeah, I mean, I think most often I have always found that the work around social justice and STEM in particular happens when people start to utilize environmental education concepts, right? And for me, it all came to life when I was in 8th grade, and I lived in a part of Detroit that obviously Detroit was a heavy manufacturing community where there was a company, a paint company at that point, because they painted all the cars, called Inmont, I-N-M-O-N-T. And Inmont was 2 streets over from my house. And, he said to me, or we had this extra credit assignment of do something in your community to explore and learn about science, because it was an 8th grade science class. And I was like, all right, well, and we started talking about chemicals. So he told me, well, you should write a paper and see how many different types of paint are over in this Inmont factory. Me being me in 8th grade, I called up my friends and said, yo, I got this assignment. We should go behind that gate and let's figure it out. They're like, oh, there's barbed wire over it. I'm like, what a gate, we can jimmy it and we can. So we fixed it up, right? And we slide in back and we're writing down all of the different codes of paint and things like that. And we see these barrels in the ground and we're like, wait a minute, right? So I go to my teacher and I'm telling him about this. He said, what? I said, yeah, and again, in Detroit, because it's heavy manufacturing, it just was, I didn't really think anything about it, right? And I grew up the street from the Kronk Recreation Center, for those that know boxing and the history of Emmanuel Stewart and Thomas Hitman Hearns, like that. We were all over the neighborhood, so we didn't know. It was just all a part of the same ecosystem, but little did I realize that there was significant risk that we were exposed to as kids around lead and paint, and the actual paint being in the groundwater, right? And it exposed a whole lot of stuff over in that part of the city. And the plant and the Inmont actually eventually closed and became a scrapyard for old cars, right? And so I think for me, an example is to really dig into environmental issues in communities in STEM and connect it to the students' lived experience. There's another one, a video that I would encourage folks to watch called Good Morning, Miss Tolliver. One of the greatest. She won the Millikan Award in the 80s. And she uses the subway and the train in New York City to teach her kids. And there's a whole video and a lesson that she does about how to use public transportation to teach kids. And again, you know, like, you can do all of those things and utilize your resources that are important to your young folks to both educate them and inspire them, but also draw in their own lived experiences, because oftentimes we think that kids show up in STEM classrooms as empty vessels, when in fact, kids are in the world and of the world and are part of the world, and they experience STEM in very different ways, but they're also experiencing science and technology and all these things on a very consistent basis. And the last thing I'll say is, I always try to encourage folks to use the outdoor space if you can. And thinking about what could be. And Robin Kelly had this concept called freedom dreaming. And it's about dreaming of what can be, not what actually is. And so for me, I believe that utilizing STEM with young people as a form of freedom dreaming and saying, how do you want to utilize STEM to advance the justice conditions in your community? Are we talking about hydroponic gardens, right, which are soilless ways of generating resources and food in your community? So I definitely think there are quite a few ways that you can do it. And then the last thing I'll say, highlight young folks who have made a difference in STEM, and highlight the people who look like our kids, right? For young women and girls, like, there's no reason that they should know who Mae Jemison is, right? It just doesn't make sense. It doesn't make sense that we shouldn't understand that Albert Einstein actually was a physics professor at a HBCU, right? And Albert Einstein refused a lot of honorary degrees, but he accepted an honorary degree, I believe, from Lincoln University, right, in Pennsylvania, right? And so there's this intersection between those who advocated for social justice and for those who read about Albert Einstein. He was a staunch supporter of the civil rights movement. He was a staunch supporter of the justice conditions and what HBCUs actually provided to young people.
Yeah, wow, so much there to unpack, Robert.
Yeah,
yeah. You mentioned the environmental issues, and we know that those environmental issues are not equally distributed across any city or any state, and there are certain zip codes that are disproportionately affected by those environmental disasters or challenges. And that comes from a history of redlining, as we know, and the social and political structures that are put in place historically that perpetuate these injustices, right? So it's even more important that young people become scientists, use their curiosity, use their eyes, make observations about their community and their lived experiences, and it's I love the idea of activating young people to be not just scientists, but also storytellers, artists, to create and express that.
Yeah, and I think to the point, there's a question in the chat. I want to make sure I say their name. It's Dr. Geddes, I believe. I want to make sure I say their last name correctly. And it talks about, the influence of KRS-One. And KRS-One was very influential for me because I wasn't necessarily into all of the randomly ignorant hip hop, right? And I've coined that term with other folks in where we do this, go shorty, it's your birthday, 50 Cent and all that is a bit misogynistic, completely misogynistic. And so for me, and I get it, right? There's an entertainment value to hip hop. But for me, as someone who grew up believing in social justice in that space, KRS-One brought forward for me something other than Two Live Crew into the hip hop space, where I could fully embrace both the art and the message, not simply the art form of hip hop, right? Because Luke and KRS-One was an art form, right? That didn't always jam with me because I was like, there's something off about this when it comes to misogyny and patriarchy and all these other things. But KRS-One spoke to me. Poor Righteous Teachers spoke to me, right? Because when I think about KRS-One, he was also doing a storytelling joint with his work. And so it also allowed me, as someone who was into STEM, to step into the role of literacy in the space, and the role of books, and the role of articles, and the role of knowledge, and how do you utilize hip hop to articulate knowledge. And you see evolutions of that with Nipsey Hussle, rest in power to Nip. And if I think about some of the things that Kendrick Lamar has done, some of the work that D Smoke has done, shout out to D Smoke for those that really know hip hop. D Smoke is the next Kendrick Lamar, where he talks a lot about the different ways in which we marginalize people through his music. He also is a African-American hip hop artist who spits lyrics in Spanish, right? So it demonstrates some of the versatility that artists can have, and he's a musician, right? So I think that there are all of these different ways that KRS-One certainly influenced me that I just think is super amazing. And there's a question in the chat from Courtney Harris. Jordan, if you don't mind, I want to talk about is in terms of like the primary barriers to racial and gender equity in STEM. And, you know, when I first started as an academic, my faculty appointment was in African American Studies and Science Education. And so when I became tenured, I was in AFAM Studies and in Science Education. And I would do these conversations, and we did a massive study for those that are familiar with the MIND Project, which you can still find online at mind.ilstu.edu. It's over 25 years old, and it's a community of scholars and practitioners that use the internet to build virtual experiences before it was actually a thing, right? And we had this NIH grant to do this work. And one of the things I discovered from doing that is one of the barriers around race and gender in terms of access was this sense of self, right? What I mean is that on the one hand, we can take opportunities to young people, right? In Atlanta, shout out to what Dr. Marsha Francis is doing with the STEAM truck, right? But it's also important to think about not only the Atlanta Science Festival and all the great work that's happening, but it's also about how do young folks show up in a STEM space? Meaning, do they understand the legacy of their brilliance, right? And so it's about the ways in which we get them to understand how to think like a scientist, but also get them to really understand how to just be thinkers and critical thinkers in the world, but also ensuring, right? And this is something that I'm working on through some partnerships through the Micron Foundation with the Latinx Education Collaborative and the Center for Black Educator Development, as well as the National Math and Science Initiative with Dr. Bernard Harris, is really thinking about how do we, in parallel, run a conversation around diversifying the teaching force, but also diversifying the STEM portion of the teaching force, right? Because this is also part of one of the barriers for young people and girls is that, you know, like what you see is what you become, right? And so if you don't see it, it's hard to imagine it, right? So for me, I saw books. So for me, like, I'm a reader because I saw books. I saw my mother reading. She was a librarian. Like I saw my grandmother read the newspaper every morning, get that paper off the porch type of reader of the newspaper every morning. So I grew to love those things, right? And so I think for me, it's about making sure that young people see it. And then the last thing I'll say is that the onus of solving this issue around access isn't simply on people of color, in particular in corporate America. It's on hiring managers who don't look like those folks who we want to hire, right? And so in other words, if we say we want to increase gender diversity and racial diversity in STEM at a university or in corporate, it's incumbent on white hiring managers to take that charge seriously, right? Because it's not something that can be solved simply by people of color and women in the field, right? It requires a movement that runs in parallel, not in perpendicular, or else you end up back at the same point. And this is the thing that I think makes folks uncomfortable is when you start talking about equity and social justice, it's the activation of the behaviors and the mindset to help you get there, right? Because again, we could say, oh yes, we have increased the number of women and people of color enrolling in engineering, yeah, but if they're not getting jobs at places like Microsoft, Micron, etc., what are we doing, right? Like, what's the outcome that we anticipate we will see? And so I think it's a matter of a commitment and an honest conversation in the field, in particular for those who claim they believe in equity and inclusion, in particular about sharing power in these decision-making processes as we aim to diversify the field.
You know, one thing that nonprofits like Science ATL and Steam Truck and my friend Takiwa Smith and Science Engineering Mathematics Link, that one of the things that we're trying to do is bring STEM professionals who are representative of the diversity of among students, so that they can see what they could be. But how do we keep doing that? How do we increase that and amplify that effort without putting undue burden on scientists and engineers of color?
Yeah, I mean, I think it's the same. Yeah, I think there needs to be a cross community conversation, right? And what I mean is that folks in education in general have been puzzling through this for a while when we think about diversifying the teaching force. What would it look like to have a conversation that's solutions oriented, learning oriented, where it's folks in education who are trying to figure this out? And again, they're amazing organizations, folks who are doing this around teacher diversity and things like that, and folks in the corporate sector who are actually trying to figure this out and are being successful at it. Because it doesn't do us any good to have this conversation to just talk about the data, because we know what the data says, right? And I think that there's, all sorts of challenges, to that. And again, and I think part of the challenge is that these conversations often happen in the hallways of central office, but not often with teachers, right? And I always say to folks, if you want to understand how to fix schools and you want to understand how to work in systems and fix systems, you got to talk to young people and teachers, right? Like that's important. And again, I'm not suggesting you don't talk to administrators, you don't talk to corporate folks, and you don't talk to these other people. All I'm saying is that the real work of education happens in the classroom, right? Like that's just the reality of it. Like that is the lever of change when we think about in changing the dynamics and the look, right, so to speak, of who's in STEM. It also revolves around supporting the needs of teachers, right? In Atlanta, if we want to have a more dynamic, diverse group of STEM professionals, and I see on one part of Atlanta, right, and no shade to these parts that have them, but like some parts of Atlanta in schools, I am sure, just like in DC and Detroit, have amazing Promethean boards and all these other things. You go to other parts, people are like, a Promethean board, like I still got an overhead projector and transparencies, and I'm rocking that out. So the question becomes, how do we give teachers the resources and the tools to educate and elevate the next generation of STEM leaders coming from our classrooms? And if teachers aren't at the table, it just becomes problematic, because it becomes like this echo chamber, right? Where you have people who have been removed from the classroom, who are administrators. And again, you need great administrators, and we need great teachers to leave the classroom to become great administrators, right? So I'm not suggesting that administrators can't be part of the solution. All I'm saying is two things can be true at the same time. And that's a fundamental premise of how I operate with social justice and equity, is that two things can be true at the same time. It can be true that we need amazing teachers in the room, but we also need amazing administrators in the room to work with teachers as equals, not in like a power dynamic, or else we're going to continue to have the problem. And the last thing I'll say is a long-term thing, is that we need to invest nationally in two things. We need to invest deeper in actual STEM education for kids in pre-K, right? Like we need to go deeper and younger in order to do that. And we need to do it in a 2-generation model where we're supporting family STEM night, family STEM engagement, and young folks. And then the last thing is that as we think about doing this work, I'm here to commit to make sure that Micron is a good community partner to support teachers in Atlanta and in the state and in the region, to make sure that we're being helpful as we work with a broad cross-section of organization. So I definitely want to make sure that folks have my contact information. I'd love to set up an advisory board of educators and administrators and leaders to work with the Micron Foundation and Micron Technology as we partner with a variety of entities in Atlanta to ensure that every young person in Atlanta has the same opportunity for super dope, culturally relevant STEM content. I don't know if super dope and culturally relevant, but anyway, for those that are hip hop, you get what I'm saying. But I think that it's super important as we move along.
Yeah, I mean, you mentioned that corporate responsibility.
Yeah.
I mean, thank you for stepping up on behalf of Micron to make that offer. It's a rare thing. I mean, we have lots of great companies in Atlanta and in Georgia that really want to be engaged in the community, and a lot of times they don't know how, and and teachers don't have the space to engage with them. There are several layers, barriers keeping teachers from talking with companies.
That's right.
And inviting companies into the classroom.
And again, this is where, Jordan, I want to work with you. I want to work with anybody on this in the room right now. We need to set it up. I really want to make sure that we do that. When I was last in Atlanta, I worked to host a small gathering of folks to talk about STEM. And it included folks from the Girl Scouts, folks from the Steam Truck, and some of our DRAM engineers from Micron. So I really want to make sure that on behalf of the Micron technology, that we're not only a good corporate citizen, but we're also operating in a way that embraces the different funds of knowledge that people bring to the room, because we all have different experiences, which means we all have different funds of knowledge, things that have informed our knowledge. So all those, please hit me up. Give folks my information. Would love to do that. Robert Simon, no S, at Micron.com. Robert Simon, SIMMON, at Micron.com. So I don't hide. You can also find me on Twitter at Robert_Simmons3 on Twitter. So feel free to ping me, want to be in community and be supportive of this amazing community, because this community gave me so much life, literally, at Crawford Long. Khadijah asked a question, Jordan, that I want to make sure I respond to around the elements of hip hop that kind of sit in my heart and my mind. And I think for me, hip hop spoke to my soul, right? In a way, like I was reading the text of Audre Lorde, Toni Morrison, and Maya Angelou. What I mean is that there are elements of hip hop that allowed me to be free, where I felt like I was confined oftentimes by the conditions of being, quote unquote, in school. Hip hop allowed me to experience education, right? What I mean is that school are the conditions of which you open the page 35, take the test, close the book, let me figure out what you've learned. Education is the experience and the journey to understand how I can impact the world and the conditions in my community. Hip hop educated me, right? School provided me insight into the nuances of the technical aspects of STEM, but hip hop educated me. It allowed me to understand the different ways of thinking about the connection between different struggles across the globe. It gave me an opportunity to understand the way that KRS-One broke down Haile Selassie, right? Like he broke it down and I'm like, yo, he's talking about that. So is Sheikh Anta Diop talking about ancient African civilizations. So you got Diop as an African civilization guru, right? And KRS-One all talking about Haile Selassie. Like, yo, this is education, because now I can see the justice conditions on the continent of Africa and how it played out in the South Bronx and the West Side and the East Side of Detroit, and I can build connections. So hip hop provided me with that education. And again, I'm not suggesting that school is not important to me. What I am saying is that in order for me to feel whole as a person, I needed education and I needed school. And hip hop provided that for me, because again, KRS-One, like he was a historian for me. Poor Righteous Teachers, X-Clan, like they were historians for me to help understand how to articulate pieces of history that spoke to me.
Robert, we got a question about the regional differences in the sound of hip hop and also social justice issues. So how is it different in Detroit versus in Atlanta?
Yeah, and then I want to come to this conversation. Somebody put in the chat their students want to know my take on Cardi B. I'm gonna get to that because I want to make sure I address that because I'm hoping that's from young folks because I love talking to young people about hip hop as an intergenerational conversation. We should sponsor a conversation about STEM, hip hop, and an intergenerational conversation in Atlanta. But anyway, I think part of it is that there's some universal truth to hip hop and social justice, right? However, to the question, everybody experiences America and hip hop differently, right? So if in your Atlanta, hip hop sounds different in Atlanta than it does in DC. In DC, it sounds different because it intersects with go-go, right? And for those that understand go-go, like that's a whole other sound, but it intersects with hip hop. And the thing about hip hop is that it intersects with other genres of music, right? Like you can't produce hip hop without the greatest band, and we can debate this, right? For those that are old enough to know this, we can debate this. But the greatest band that provided instrumentals for hip hop were the elements of EWF, Earth, Wind, and Fire. So you can't have hip hop without Earth, Wind, and Fire. But you can't have Earth, Wind, and Fire without the beautiful sounds and the melodic sounds of a Thelonious Monk, Miles Davis, right? So all of these things are kind of scaffolded. And I think regionally, that's how I understand both hip hop and social justice, right? And the justice conditions, because things are kind of scaffolded on top of each other because things look different, right? And so when I think about the justice conditions in Detroit, in particular, I also think about the ways in which it positively impacted the Black middle class in Detroit. But I also think about the negative ways where the plant and working in the refineries and all these other things actually took the life of my grandfather, right? Where I just think about the conditions that they worked in. So on the one hand, the justice conditions in Detroit were about the power of the United Auto Workers to create the Black middle class, but it also requires a bit of nuance. So I think it's important to dig into the nuance of it all. And I think it intersects with conversations around gentrification and things like that. And again, hip hop sounds different in every place. Like when I first heard Outkast, I was like, yo, this is different, right? Because it had this like distinctively different sound, right? Similar to when I think about one of my favorite hip hop artists in Detroit was Esham, right? And then thinking about some of the work that's happened in Detroit or some of the hip hop in DC or in New York, there are different sounds. You think about the West Coast, it's a different sound, but also the justice issues in these different communities are important. And I think that helps us frame our STEM pedagogy to be responsive to those particular things. Now, I want to close with, I got like 2 minutes, Jordan. I want to say this right before you close. Now, Cardi B is an acquired taste, right? Part of it for me, I appreciate hip hop artists who are also musicians, right? And play instruments, right? So I want to give that as a caveat, right? That I am biased and I'm owning my bias, right? But I also appreciate Cardi B, not necessarily because of her lyrics. Sometimes her lyrics, to me, are questionable at best, right? Because I think they perpetuate particular stereotypes of Black women, right? But what I do appreciate about Cardi B, because remember I said, two things can be true at the same time, right? It is true to me. My truth is that sometimes I question her lyrics, right? Like, I don't know if I would say that, but I get it because it sells. It puts money in your pocket, and Cardi B puts money back into the community. I got that part. But I also understand the hip hop community needs Cardi B because Cardi B stands on the shoulders of Jean Grey, Queen Latifah, etc., MC Lyte, Remy Ma, all these other people, right? And in hip hop, we have a problem with acknowledging the ways in particular in which Black women have influenced the art form, right? And acknowledging their brilliance as artists as opposed to being objects of objectification in hip hop music, right? And again, two things can be true. Hip hop can inform the social justice movements of our time, but hip hop also can be deeply problematic for the ways in which it talks about women, right? And the ways in which it perpetuates stereotypes about Black and brown women in particular, right? And so I think that this is the bit of the hypocrisy that I struggle with and I live with. And this would be my challenge talking to that group of young people, is that how do you reconcile as young people who would say to me, well, Robert, yes, Black Lives Matter. Okay, I hear you. But then you have to reconcile that that music is not articulating to you that all Black lives have the same value position and value proposition. And that's why I think STEM and the ways in which engineering principles, when we begin to think about looking at variables and considering how we make an argument in STEM, is applicable to doing an analysis of the problematic nature of hip hop, but also celebrating and acknowledging the beauty of hip hop. As a hip hop head, I live with it every day. And I find that with our 11-year-old, I have that conversation with him all the time because he's always schooling me on some of these new hip hop artists that I've never even heard of. And I'm like, who is this? And then I listen to it and I'm like, yeah, we need to have a conversation because some of this, I don't know about it. But again, it's the same conversation that I would have. Just in my case, I had to have that conversation in the barbershop and with other homies because of my father's incarceration. So I'll stop there. Everybody should have my contact information. Jordan, I appreciate y'all having me. Folks, please hit me up, whatever I can do to be helpful. And I'm just excited to be a helpmate for all the amazing things that y'all have going on, not only in Atlanta, but in the state of my birth, Georgia. So.
Dr. Robert Simmons, thank you so much. Everyone give it up. I know we can't hear you, but please give it up wherever you are. Thank you so much. I dropped 2 links there in the chat. A shout out to some student artists who, the first one, the Immortal Rap of Henrietta Lacks, is a group of middle schoolers in Oakland who made this great song. It's fantastic. And then a few years ago, another nonprofit in Atlanta, Reimagine ATL, worked with some students at Frederick Douglass High School and APS and made this awesome STEM rap PSA. So please check those out. But thank you all for joining us for Hip Hop, STEM, and Social Justice. I'm Jordan Rose with Science ATL, and we'll hand it back to you, Heather. Thank you.
Thank you so much, Jordan and Robert. What a great conversation. I think I put like 3 emails in your inbox, Robert. so FYI on a few things that we can follow up on. And Jordan, I'll hit you up on a couple things too that came up on my mind. So thank you for your time, and we will be in touch. Thank you so much. All right, everyone, we are going to now bring up David Hanks. David is a nuclear engineer, and he is going to talk about his STEM career in nuclear engineering. So David, if you can please come up, that would be wonderful. Oh, you are up. Thank you for joining us, and I'm going to pass it over to you.
Okay, thanks, Heather. I have a short presentation, and then we'll answer some questions for anyone that wants to talk about nuclear energy. A little bit on my background. I am a nuclear engineer. I started out
Hold on one second, everyone. I'm going to try and get his Wi-Fi up.
Okay.
David, are you back?
Yeah.
Okay, hold on one second. I'll let you share screen.
Okay. Can you hear me okay?
I can.
Yeah, so I'm not sure how much of that you got, but I have a short presentation here that I'll put on the screen. And for those students or folks interested in careers in nuclear power, this may be an interesting presentation for you. Let's see if I can go back to. Heather, can you see that?
I can. You're good to go.
Okay. So this is a presentation I put together for another organization called the Technology Students Association of Georgia, and it's about careers in nuclear energy. To begin with, I talked a little bit about the different kinds of energy present in the world: nuclear, fossil fuels, wind, solar, hydro, and geothermal. All these are providing power to your major power grids across each country in the world. For the US, we have a 500 kV backbone to our power grid, and most of these types of energy producers feed into that 500 kV line, which then is transformed down to the cities and communities to supply power to your house. Many things to think about with nuclear energy and all these energy sources is the global challenges that they provide, especially in environmental impact, safety, culture, security. That's guns, guards, and gates. Safeguards is more of materials like nuclear materials. Safeguards to ensure that these dual-use items are not being used for anything but their intended use. Medical applications, of course, is a big part of nuclear research. And of course, waste disposal is on everyone's mind. Spent fuel waste from the nuclear reactors has always been an issue. Many countries are beginning to look into repositories, and that's moving forward. Just as a thought or something to think about when it comes to job benefits for the nuclear industry in particular, is we have very competitive salaries, flexible working schedules and hours. Of course, nuclear power plants run 24 hours a day, 7 days a week. You can't just walk away from a nuclear power plant. There's no switch to turn off. You just have to stick with it. Of course, all the U.S. companies have health benefits and retirements and life insurance programs, including paid time off, annual leave, sick leave, and holidays. I can't see any questions come up, so I'm not able to enter the chat, I don't think, until I get done with the presentation. So if you have a question about some of these job benefits, please feel free to put it in the chat, and I'll try to answer those as I go. If you can see this slide, it talks about workforce income. I won't go over the whole slide, but at the bottom there's a chart that talks about the technologies, the energy technologies that I just mentioned earlier. And nuclear, of course, in the final column has the highest workforce income per capita for the type of energy production. So you can see that and kind of gauge that against the government's idea of the value of a nuclear engineer. This is a graph from 2015 that I have. And of course, it's, the pay rate is more than it is now. Today's pay is much more than it was in 2015. Bachelor's degree program back in 2015, the first year started at 62,000, master's at 67, and a doctorate at 81. But you can see over the first 5 years, the growth in salary is tremendous for nuclear engineers. So you can imagine what a great industry it would be to come into the workforce. There's over 100 nuclear power plants in the US alone. There's about 460 or so in the world operating today. But most of these power plants are located on the East Coast. There are some in the Midwest and in the West.
David, you're muted. Or your Wi-Fi is down.
Sorry, I got cut off again. I'm going to try this one more time and see if I can make it happen.
Hey, David, if we lose you again, I'm going to move on to the next one, just FYI.
Yeah, I apologize. I'm here in Augusta, Georgia, so the bandwidth here is, I guess, not wide enough to handle big conferences like this. But anyway, nuclear power school, I began in the Navy, which is a good start if you're thinking about going into engineering and not quite ready for go to the university or college. It's a good start. They pay you to learn, and you spend at least 2 years in training prior to going out to the fleet. So it's a good place for people to start when they think about nuclear engineering programs and operating nuclear reactors in particular. I work for like I said, IAEA in Vienna, Austria. This is a picture of the building there in Vienna. And it's a great place to get a better education and understand how the world works as far as nuclear power goes. I did most of my inspections in the European theater. I had about 16 different countries that I visited doing inspections of their nuclear materials and activities. Mostly in Europe, like I said, country officer for Romania, Slovenia, Sweden, parts of Germany, the Netherlands, and the UK. So it's a very interesting organization to work for. And if you have any questions about international United Nations programs, just let me know. We can get together and talk about it a little bit more. But I just thought I'd put this out there for those that see this as a higher career. Like I said, I began in the United States Navy right out of high school, got my degree after leaving the Navy and joining the utility. And then I became an inspector after 25 years of operating reactors. So it's one of those things that are later in your career. They would really like to have experienced people doing the inspections of these facilities. Globally, like I said, there's about 439 operating reactors in the world. At least 60 new reactors are being built today. Many of those are in China, but we have 2 here just outside of Augusta, Plant Vogtle, being built and under construction. They should go online in the next 12, at least the next 12 months. So be looking for that. And over the horizon, we see a lot of new reactors coming online and a lot of research and development in these small modular reactors, which are reactors that are used to power small sources of energy and microgrids and things like that for maybe one city or even one hospital, for example, if it was small enough. I worked for the Nuclear Regulatory Commission for about 10 years before I retired this last December. And the Nuclear Regulatory Commission regulates all the nuclear power plants in the US and that are licensed, and their operators are individually licensed. And those operators are held accountable for any actions they do in a nuclear power plant.
My apologies, everyone, that we keep losing.
Heather, I'm on just in case you want me to like step in at some point.
Yeah, let's go ahead and get started if you don't mind, Braden. I will have Dr. Hanks do a new video, and I will insert it inside this video that will go out at a later date. So everyone, please look at the recording at a later date, and we will have David present on this further. Okay, thank you so much. Thank you, David. Sorry.
Sorry about that.
Okay, thank you.
All right. Do you want me to kind of move into it? Is that okay?
I would love for you to go ahead and get moving into 3D printing. Thank you so much, Brady.
Okay. Sounds good. Thank you all so much for having me here. I hope you all are excited about this. We're going to go through a couple of things. I'm going to tell you a little bit about my story. We're going to talk about Tinkercad. We're going to talk about some of the stuff going on in the 3D printing industry. So are they able to ask questions in here, Heather?
They can. It'll be in the Q&A or the chat right to you.
All right. All right, great. So we'll just start diving into it. Once again, thank you all for having me. I'm part of a company called MimioSTEM now, but I'll tell you a little bit about my story. So hopefully you can see my screen. Is that being shared? Are we good? Okay, so I'm one of the founders of a company called Robo 3D Printers. Not sure if you've heard about it, but we've been in the 3D printing space since 2013. You'll see some of the images down there of machines that we first built. So it started out as a really organic journey. My business partner was actually building 3D printed prosthetics in college for mechanical engineering. And if you know anything about prosthetics, for all of you that are out there, they can be very expensive. So 3D printing was a more affordable alternative to being able to do that. And so we started building prosthetics and then quickly realized we wanted to build our own 3D printer. And we began that journey. And you know, a lot of people ask me, how did you build a 3D printer from scratch? What were you doing? And, you know, I tell them the simplest thing possible, right? We just went to YouTube. So we went to YouTube. We watched a lot of videos of other people that have built 3D printers. We learned how to do it ourselves. We made our own machine. We created a really cool look and profile for it. And then we launched it on a platform called Kickstarter.com, which hopefully you all have heard of. And, you know, fortunately for us, we had a goal of, on our first campaign, of raising about $49,000, and we ended up raising $650,000. And over the course of my time doing 3D printing so far, you know, we've been able to raise over $1 million in crowdfunding. So it is a great alternative if you have product ideas out there and you have a passion for building stuff. You can use Kickstarter as a platform to really get your idea off the ground. And, you know, on top of that, just like, you know, some of the cool things I've done, one of the greatest things and one of the biggest honors I've had was being in the 2017 Forbes 30 Under 30 class. So done a lot in this space. I'm really excited about it. I love how it's impacting every major industry. We'll talk a little bit about that, but you know, it's one of those technologies that I quickly realized gave people the power to create and build things from scratch. And that's something I wanted to enable with students in the classroom and with people all over the world. So, you know, I talk about these people, and you may or may not have heard of any of these young kids, but these are kids that were exposed to 3D printing technology and did incredible things. Okay, so if you look at Easton LaChapelle there, he's a young kid that started a prosthetic 3D printing prosthetic organization called Unlimited Tomorrow. You can look them up, and they design affordable, functional 3D printed prosthetics and just incredibly like innovative prosthetics. So, and that started with just his exposure to this technology. The same thing with Ayla Hutchinson, if you can see her there. She was in New Zealand, and her mother actually cut off her finger while doing something with a hatchet, and she was able to create a product with a 3D printer that, you know, helped with safety of being able to use certain equipment where she grew up. You know, Anne Makosinski in there, she developed a flashlight powered by hand for her science fair. So, you know, there's just some incredible stories that happen and will continue to happen. I'll tell you about some of our customers here in a minute, but when, you know, exposure to 3D printing happens at a young age and the ability to design and create happens. So we'll talk a little bit about that. I just wanted, actually, I had a question. I don't know, Heather, if this is okay that I ask it. I just kind of wanted to get, you know, maybe this isn't the best place to ask it, but I threw it in here anyways. Just wanted to find out if anyone have used the 3D printer or have you designed anything in 3D modeling softwares or anything like that. Should I refrain from doing that, or is that okay?
You're fine by asking. People can type in.
Okay, cool. So I'm looking at the chat box. So it seems like we have hopefully some people that are in here. So if you just can respond in the chat box, if you've used 3D printers before, have you designed things? So it looks like we have some teachers in here too that said yes. Some of my students have. That's awesome. No, once. Okay, so and we'll talk a little bit about this, and I'll show you, you know, some things that you can do here in this side. We have not, yes, so a little bit of mix, probably half yes, half no so far. But we'll kind of dive in and I'll talk to you a little bit about some stuff you can do and about some resources. So let's go ahead and go to the next slide here. This is something, just wanted to take a step back. We're in this time of the pandemic, right? And I just know the power that 3D printing and 3D design can have in the days like today. And I'm sure all of you have heard or had heard the stories when the pandemic first started, how powerful the 3D printing community came together and developed, personal protective equipment for hospitals and clinics and things like that. And the ability for that community to come together was based on the fact that they learned how to do 3D modeling and 3D design. They had access to machines that could make things. So we had the power to be able to come together and donate. I mean, you're talking about hundreds of thousands of pieces of personal protective equipment for hospitals and clinics. And so this was ones that we designed, we donated, we were able to donate over 3,000 3D printed face shields, masks to all different types of hospitals and clinics around our local area and some of the areas that our customers were in. So it was just a really incredible time and showed how powerful and how important this community can be if we get more students and more people around the world doing 3D design and 3D modeling. Talk about the power of 3D printing, right? So you might not know this, but once again, every major industry is being benefited by this technology. A little story about my first employee in our engineering team. When we were a small team, we only had about 6 of us at the time. He sort of started building our engineering team. He went off, moved to LA, and he got a job with SpaceX. And he is now running the multi-million-dollar metal 3D printer that prints rocket parts that goes on all the SpaceX rockets. He has meetings with Elon Musk all the time. And it's just really incredible to see just in that, a lot of people don't know that rocket parts or airplane parts and all these things use 3D printing in them. So you talk about engines, both rocket, car, airplane engines, all use 3D printed parts. You look at an industry like organs, being able to 3D print organs, right? Actual body parts that will go into the human body at some point. That's a really major industry. It's called bio 3D printing. That's happening right now. And it's not far-fetched to think in the distant future that, we're going to be able to replace any organ we need to with a 3D printed organ. Product design, Nike, all the major brands are using 3D printing to actually create products that they sell on the shelf. So both product design and prototyping and product design and being able to 3D print products. There's people on kids, even young kids on Etsy that have Etsy stores that are making 3D printed parts and selling them to other people. So there's lots of cool stuff that can go on the product design. And then homes, they're making homes in 24 hours using 3D printers. And there's a company called Icon, ICON, that makes a kind of a massive home-sized 3D printer that actually prints concrete and builds layers upon layers until you have a home. So it's pretty cool stuff. So a little bit about our stories. I want to talk about these and then we'll talk about Tinkercad. But a couple of stories that happened. So we, at Robo3D, we have a curriculum platform called mystemkits.com. So it's a way we link our 3D printer into mystemkits.com, and then we have hundreds and hundreds of K-12 lessons that allow teachers all over the country to use a 3D printer to teach math, science, history, language arts, things like that. It's really fun and really simple. And so we want to get more teachers excited about using this technology in their classroom. So Shelly and some other teachers I'm going to show you are a great example. They started with this platform, and then they went and did some incredible things on their own. So Shelly is a 5th grade teacher in a small town in Montana called Big Fork. She was exposed to our 3D printers, our curriculum, got comfortable with it. She was at home one night watching a documentary about how coral reefs around the world were dying. She said, I want to make a difference in my class. We live in a small town. These kids don't think they can make a difference in the world. And so she went to her classroom and they started designing coral reefs in Tinkercad and making a coral reef wall in their classroom. Okay, so it was all 3D printed coral reef. Then she said, I wonder if we can work with scientists, coral reef scientists and marine biologists, and actually make structures that can be planted in the ocean and coral can grow and live on it so we can rebuild the coral reef population. And so they've been actually working on developing these artificial coral reef structures made of a material, it's an algae-based 3D printing material that can be planted in the ocean. And so these kids now in this 5th grade class are just so excited that they're actually making something that's impacting the world, that's saving the ocean, that's saving coral. And so this is the type of stuff that I just love that's happening over and over again. We have a school in California, Calavera Middle School, that they have an after school program, and they're working with an organization called Enable, and they are building prosthetics for kids all over the world. So Enable is connecting them with young kids that are in need of prosthetic hands, prosthetic legs. And this school and this after school program, you'll see some of the prosthetics that they have there, is building custom prosthetics for these kids, which is really incredible. We have a school in Massachusetts that built a website on Wix, which I'm sure some of the students, if there's some students in here or even teachers, maybe have built a website on Wix. But it was a cool website where they went out to the parents and they went out to the community members and they said, hey, we built this website. All we want you to do is submit an invention to it, and we're going to have our students design it and print it. So they had people come to them with like the perfect bagel cutter or some things like that, that they got their kids into, or their students into groups, and they were able to design solutions to these inventions or design actual products to these inventions and deliver them to that end user. And if the end user wanted to take it to the next level and make it into a product, they could bring on those students as part of the company. So it was a really cool program that they developed. And, you know, it's all started with a simple Wix website to submit an idea. That's what the website looked like. So you just post your problem or post your idea. The students get together, design a solution, and, you know, they're able to share that with that person. And then, you know, I always talk about what happens when students are exposed to this in the classroom, right? So if students are exposed to 3D printing and exposed to 3D design and 3D modeling and create products from scratch, we start to see these stories take shape. And Max is one of those kids, a California kid, really local to where I am. I'm located in San Diego. I'm actually on a business trip right now at a trade show in North Carolina, but located in San Diego. And Max was able to learn 3D design in his classroom, and he went home and he decided that he wanted to take his normal skateboard and turn it into an electric skateboard. And so he created a electric skateboard, battery pack, everything. He 3D printed the casing around it and did that. And he started a company called Felonious Skateboards, and he's selling electric skateboards that he's developed. And it started out with doing a 3D design on the battery pack. Riley, another young kid, did some really cool things. He designed lots of these little trinkets and fidget spinners and things like that that he could sell to students, community, parent members, and fundraise so he can build a 3D printed club at his school. And so that was one of our older models. And I think the last time we talked to him, he raised over $5,000 and you know, was able to start this club and teach other kids how to do 3D printing. These are just two of the machines. I just want to mention those. So we've been a long way. We sell only into education now, but these are two of the machines that we have. So anyways, talking about Tinkercad, what is Tinkercad, right? Tinkercad, if you have not used it, it sounds like some of you have, some of you haven't. Tinkercad is a free 3D design software online. It's web-based, it's a website. You can go to it. If you're a teacher that's on here and you haven't used it, you can set up what's called a Tinkercad classroom, and you can invite your students to come and design in your classroom. Now they'll have their own screen. I'm going to show you how it works. And but they'll be able to design, and you'll be able to monitor kind of everything that they're designing. Now, what's so cool about this is we have in our mystemkids.com platform, we have design challenges that students can design rockets, they can design homes, they can design boats, they can design derby wheels or derby cars, and learn how to do the basics of 3D design. And that will help them kind of realize that they can look at the world a little differently. They can see things that they can design, create, and build from scratch. So I'm going to move over into Tinkercad. I want to show you that real quick. So let me bring back up my screen. I'm going to stop sharing here. And I'm going to bring up Tinkercad because it's on another window. Is there any questions that came in, or are we good?
Is 3D printing only in plastic or materials? Other materials? I think other materials, right?
Yeah, great question. So 3D printing can be done in the technology of 3D printing. If all of you have not seen it or used it, right? What we mostly see is a machine that makes plastic. It melts it, it draws a layer, it moves up, draws a layer, and it builds a three-dimensional object, right, from scratch. Now, it might be depositing plastic in those machines, but there's other machines that can deposit concrete. There's machines that can do like metal, and it's different types of technology, but they can use all different types of material, rubber material, metals, nylons. There's machines that use resin. So really the idea of 3D printing is that you're building something from scratch. Good question. Any other questions, or is that it?
What's the name of the 3D kits?
Okay, so yeah, mystemkits.com is the name. So we at Robo 3D, if you look up Robo 3D printer or Robo 3D, I can put my contact information in the website or on the chat box as well, if you guys want. I'll do it in there in a second. But just Robo 3D, our 3D printers kind of pair with this curriculum platform at mystemkits.com. So you have like the machine, you got the curriculum, and it all ties into one umbrella of ease of use and actual curriculum that you can use in your classroom. So we have curriculum that goes, like I said, from K to 12, math, science, history, language arts, all sorts of stuff that you'll see in there. So you can go check out mystemkits.com. You can sign up for a trial if you want to look at it. And I'll put my information in the chat box so you can actually reach out to me if you have any questions. But I'm going to dive into this and just show you this before I hop out of here. But that's my actual email. So we actually joined a company called Boxlight. We were acquired. So I now run the STEM division at Boxlight. So I'm responsible for a couple of different STEM products, but all of them incorporated in mystemkits.com. So going back to Tinkercad, this is like where all students learn how to do 3D design. The reason we use Tinkercad is because it's made by a company called Autodesk, okay? Autodesk is a company that has lots of other 3D modeling softwares, okay? So Tinkercad is gonna be its basic, free, education-focused 3D modeling software, but then they have ones like Autodesk Fusion 360, Autodesk Inventor, and things like that. So students can grow their 3D modeling career starting with Tinkercad. So this is very bare bones, but I just wanted to show you how this works, okay? It's really simple. A lot of people, when they talk to me about, I can't design something, it's too hard. I'm like, no, just go use Tinkercad, you'll figure it out. And so the reason I say that is because it's free, but you pop into here, they give you a work plane, right? This is your 3-dimensional work plane, okay? Everything over here on the right-hand side is basic shapes, okay? So you can start with the basic shape. You can start with any type of creature, vehicle, machine. You can start with simple design starters. So there's lots of different things you can look through and start with, but I always start with like basic shapes, right? So you can drag shapes over here. You can kind of start sort of building and creating, if you want to build like something like a rocket, right? For example, you can sort of start taking things that would go on your rocket and start kind of, and I'm doing this just for the sake, this is very quick, but I just wanted to show you how simple this really is, right? So, I have my little rocket now, and I can start building, maybe if I want to build some like legs for it, for example, or some fins for it, you can start doing things like that, right? And so you can start messing around with this and building different things, okay? And then this is actually going to be a terrible design, but you guys hopefully will get the gist of what I'm trying to do here, right? So let me move this around a little bit. So you can see, pretty quickly I can just start manipulating things. That's a terrible rocket, but what you do after you've kind of designed and built things, you just kind of select them all, you group them together, and then you can take this model and I can send this directly to a printer, okay? I wanted to curious who's used and who's designed in Tinkercad. I think some people have. If you have, type in the chat box. I see a couple of questions. I'll answer those too. How are 3D printers made? Our 3D printers are made overseas, but they're really built like any other piece of manufacturing technology. So they have rods. They have a platform that they have a thing called a hot end, which is basically like a glorified hot glue gun. That's what melts the plastic and draws. And then they connect into a software, and the software kind of tells the print head where to go and what to do. So it's really easy. It uses, I don't know if you've heard of Arduino before or something like that, but a lot of the original 3D printers that we built used Arduinos. And so that was the circuit board or the electronics board that powered the 3D printer, that made the motors move, that made the filament gear move, that made the hot end heat up. And that's how you kind of built it. Can we use recycled plastic in 3D printing? Yes. So the plastic we print with mainly is called PLA. It's a biodegradable plastic. It's made from corn. That is the one we recommend all the time. But there is other recycled plastics like this algae-based plastic. and things like that that are out there. And so the machines we have, you can use any of those materials. Will Tinker communicate with any printer? Okay, so there's kind of two things with, a lot of people ask that question. It's a great question. So Tinkercad is a 3D modeling software. So anytime, say I just created this really terrible rocket that's not going to fly anywhere because of this weird wing that I did here, I can export this now. So I can press export and I can save it as an STL file, okay? Any software that allows you to print to a 3D printer prints STL files. So you can use any printer that exists out there. You can design in Tinkercad, you export it as STL, and then you go to print it, because our printers print, they take STLs and they convert them into a file that they can print. So I can just take this model now and I can go to my software. I can upload it into my software to actually print to my printer, and it will do everything from there. STL stands for stereolithography. So STL has been around for about 30 years, and a lot of people don't know 3D printing has been around for about 35 years now. So it was started with a different type of technology, but now it's become, affordable and easy to use for, schools and for, people in their garages and things like that. So STL, stereolithography, it's the file format that all 3D printers use. Stereolithography, sorry. Yeah, so it's basically what a JPEG is to a picture, what a PDF is to, a document file. That's what STL is for 3D models. Okay, so hopefully that made sense. Yep, no worries. Yeah, please, any other questions that you have in here, please ask. So yeah, that's kind of the basis of Tinkercad. We have a lot of design challenges where we walk students through how to do basic design step by step, and then they're responsible for coming in and iterating on this design, okay? We want them to sort of take what we've done. I'm gonna flip this around so I can make a better rocket, because the one that I did was terrible. We want students to kind of follow along with what we have, but then come up with their own ideas, right? And so that's a lot of what we think about when we're doing design and modeling, is doing that. And so yeah, once again, shape base, you can drag text over here, you can change the text, put your name. How much time do I have left, Heather? Am I getting close to time?
I think you have, 10 more minutes or so. Feel free.
Okay, cool. So you can take text and you can embed text onto it. You can do lots of cool things. We have lots of schools that sort of are making trophies for sporting events and doing all sorts of stuff like that. So, I can obviously flip this if I want. I can make it smaller. So lots of stuff that you can do, but just wanted to show you guys how a little bit of this works. So it's and you can press control and kind of view it from 3 dimensions just to see what the stuff that you're designing looks like. And then once you're done, you just select it all, you group it together, and you have a full design that can be printed. Now, tinkercad.com is what it's called. So you can see it kind of in here, tinkercad.com. You can sign up for a free account. They have lots of videos that are much better than this quick demo, but they'll walk you through step-by-step how to use this. And once again, in mystemkits.com, we have design challenges that walk students through how to do this too. But I've taught at so many different camps and things like that. And students that I teach this to, I've done STEM camps, space camps, things like that. And I'll kind of walk through the basics of 3D modeling using Tinkercad. And within 5 minutes or so, these kids are already designing things that are probably better than I could ever design. So they can get this pretty quickly and they can use this software. And once they've designed something, they can take that and print it to the printer. All they have to do is export as STL, go to the software and just press print. And I'll tell you, a lot of students that maybe don't feel very empowered in the classroom, things like this, being able to design something from scratch, send it to a 3D printer, print it, hold it in their hand is like one of the most magical moments to watch. So highly recommend it. I hope you all are, got some good ideas out of this. We're inspired about some of the other stories that people are doing with 3D printing. And also, I just wanted to talk about the importance. I've been in this technology for about 10 years, and I've seen the impact that it's had on positive impact that it's had on so many industries. I didn't mention food is another one as well. They're doing 3D printed food, desserts, custom design desserts, things like that. So it is one of those technologies that is sort of the crux or the foundation, of a lot of different industries, advances or creativity, or product design, whatever it may be. So thank you all so much. I don't want to take up too much time, but if you have any questions, I would love to stick around and chat about the specific technology. Do you know of a platform or company that I can send my student models to? I don't know if you want to get them printed because you don't have a 3D printer. Is that what you're asking? Okay, it'll be another 6 months to a year till we get a 3D printer. Okay, so there is, blanking on the name of the actual company that does it, but there is, here, I'll find it for you. There's a company that does print 3D models to print, that does actually print STL. It's called Shapeways, that's it. So it's fairly expensive, but you can send them an STL model and they will print it out and send it to you. But that's, you're talking, they're industrial and it might be a little expensive to do that for all the students. It's going to be much more cost effective to get a 3D printer yourself at some point. I will say that we do grants and things like that. The machines are very affordable. I mean, they're only like educator pricing on them around, it's like an $850 program or a $1,600 program for the bigger one. So something to keep in mind. I just want to throw that out there.
I would also say, Mrs. Smith, if you want to connect with me, I might be able to find somebody for you as well. So depending on your locality.
Yeah, I'm sure we can figure something out where, we want to get this type of technology into schools that are interested in, implementing it with their students, allowing, not only to have it being used to enhance and create hands-on projects for some of the stuff you're already teaching, but also to allow students to do design and engineering. That's a big part of it. Any other questions? Did I miss anything on here? I'm going back. Someone said I made an Iron Man statue at my Boys and Girls Club. I love that. We actually have a customer who designed an entire Iron Man costume. And so I'm going to pull it up for you real quick before I get out of here because I want to show you that. And it was pretty awesome. So we've seen just some incredible customer stories about how they've used the product, but this is a Iron Man costume that one of our customers created. So you can see how it's very advanced. They painted it, they sanded it, they primed it, but yeah, you can do a lot of incredible stuff with the technology if you put your mind to it. There's also, for all of you that don't know or have 3D printers, there's a website called thingiverse.com. Verse is in the verse of a song.com. And there is millions of free models that the community of 3D designers has made that you can download for free and print. So it's a good resource just to have if you ever are like, I need a toilet paper holder, right? Someone's probably made one that's really cool design that may be a theme of a movie, and you can go in there and you can download it yourself. If you have a printer, you can just print it directly. So I use that example because I did that recently to one of my houses that we were remodeling. So any other questions? Are we good? Thank you all so much for having me. I appreciate it so much. Thank you, Heather, for bringing me in last minute.
Yeah, absolutely. Thank you for doing this, Braden, and then jumping in when we were having some technical difficulties. So
yeah, no worries. I'm
appreciate
glad I was on email when you sent me that. So
yeah, thank you so
Thank you
much,
all.
and we'll be in touch.
All right, sounds good. Take care, guys.
Thank you.
Bye.
Bye. All right. Now we're at our last session today, and that is with Perscolis. We have a board member, Michael Sullivan from Georgia Power, that has talked highly of Perscolis. And today we have Sherry Sims and Danielle Clark here to discuss what all they do. So I'm going to send it over to you guys, and I'll just be in the background if you need me.
Awesome. Heather, thank you so much for that introduction, for working with us. We're super excited to be here with you all today. My name is Danielle Clark, and this is my manager, Sherry Sims. And we are going to just jump right in and tell you a little bit about our organization and some of the awesome opportunities that can really be afforded to you all. Give me 1 second here to share my screen. Okay. All righty. And so this is just a quick overview. Here at Perscolas, we are a national nonprofit organization that's been advancing economic equity for over 25 years. And so really what we do is we train for tech careers, including professional development, pouring that all into our learners and connecting them with employers all throughout the Atlanta region. And we're able to get them jobs in technology. I'm going to play a quick little video for you all to hear a little bit more from our president and CEO and kind of a firsthand account of some of the people who have been through this experience.
Congratulations, you found Perscolas. We train people for careers in IT, careers that allow people to build amazing jobs and take care of themselves and their families going forward.
Before I came to Perscolas, I worked easily 12 to 14-hour work days.
I was waiting tables and I really wanted to break into the tech field.
I drive for Uber and it was really hard job.
Before Perscolas, the next week was just, I didn't know what was gonna happen.
I was born in the South Bronx. I grew up right here in this building. There was really lack of opportunities in my neighborhood. And so I decided to do something about it. I've spent my entire career trying to create opportunities for people who live in communities like the South Bronx. And so Perscolas does just that.
I actually heard about Perscolas from my sister. She told me, hey, there's this cost-free class that you can take. It's full-time.
I found Perscolas and it says tuition fee. I didn't believe, but I just tried. Let me try.
My Perscolas experience was great.
Learning about hardware and different operating systems, it came natural.
A lot of us had no background in technology. The instructors made it seamless.
I never did well in other learning settings, but Perscolas really gave me a way to tap into my best self.
I got the AWS, Network Plus, Security Plus, A Plus certificate with the help of Perscolas.
They gave me free training, all of the materials that I needed, and a seat at that certification exam. All I had to do was bring the desire to learn.
For 26 years, we have been providing IT training to thousands of Americans across this country, allowing them to build the skills to enter into the amazing careers in companies all over the world.
I am currently employed, and it is a direct result of Perscolas.
When I saw that there was an opportunity to join the team, I jumped right on it.
I was driving Uber because I have to survive. Now, I have this job, which is my dream job. You can imagine how satisfying it is.
As of today, I was just offered a position from intern to engineer. That's what I love about IT in general, is the unlimited potential for growth.
To be a woman in this field and to also be a person of color, a Black woman, I know that I am breaking barriers. It's empowering to show my learners a different face in tech or broaden their idea on what a person in tech looks like.
They don't get you a certification, get you a job, and then say, hey, take care, good luck. They'll say, hey, here's more. What else do you need?
The most rewarding part of being an instructor is putting someone on the path towards a new career and being their biggest cheerleader.
Often people are worried about how do they pay their rent tomorrow or put food on the table. You can't be forward thinking if you're worrying about the moment right now. And so once you build these careers, once you're able to land these great jobs, you can think about your future. You can think about your family's future. You can be part of the community in ways that perhaps you weren't before. I hope you give us a chance because you deserve that opportunity.
All right, awesome. So I think that was a really great introduction.
Congratulations.
To really kind of what we are about and what we do. We've been able to really transform a lot of lives by giving them an opportunity to have a different career path, a non-traditional way. I know a lot of people expect everyone to go directly into college after high school, for example, but, there are other ways that you can set yourself on a successful path. And Perscolas is just one of those ways that we are here to help people in our community to really change their lives. So for our programs, we offer three main programs: IT support, software engineering, as well as cybersecurity. Those are our main focuses, and throughout these programs, you're able to obtain various certifications and gain professional development skills to really help you, sharpen up those resume skills, those interview skills, and allow you to be presentable to employers in the future. And so we also have a professional development side and team that handles that. Our most popular course that we offer is IT support. This is, open to everyone. You don't need any type of tech experience, and really you can just come into yourselves. It's 12 weeks long, and at the end of this program, you are able to obtain your CompTIA A+ certification as well as your Google IT certification. So something that's really cool about this particular program is that it is beginner friendly. And so once you're done with this, you can, become a field technician, a desktop support, a driver technician, or an IT support technician, all at the entry level, just by taking this 12-week course exam. Our next program that we offer is software engineering. Like I mentioned, this is 15 weeks and typically is given remotely, and it's a project-based course. And so in this, you'll be learning and building up your portfolio, working on the front and back end, learning the different coding and the different coding languages. And, when you're done with this, you can become a front-end developer as well as a back-end developer or a junior developer. And one of our newest courses that we've offered to our program list is cybersecurity. Cybersecurity is pretty awesome and it's needed right now. We've made this transition really into a virtual space almost, out of force, but it's been an awesome journey that everybody has really kind of transformed into this tech space. And so we've added cybersecurity onto our program list, and this is also 15 weeks of remote training. It's going to be a mixture of building up a portfolio as well as taking different assessments. And at the end of this, you're able to obtain your cybersecurity A+ certification, which is pretty awesome. And some of the jobs that you can obtain with this is becoming an information security analysis or cybersecurity analysis, doing network security, or being a security engineer. And so these are just some of our upcoming courses that we have. I know this might not be applicable to everyone, but if you know anybody who's interested in transferring their skills, changing their career paths, or if you're thinking, college might not be for me, I might want to start working into, the job field. This is a great opportunity. We are a tuition-free based organization. So all you need to do is bring yourselves, your dedication, your hard work. All of our classes are offered from 9 a.m. to 4 p.m., Monday through Friday, just like a traditional school and class that you're more than used to. So it's a really great opportunity. Like I said, these are our upcoming courses that are set in place to take place for the rest of the year. And yeah, at this time, Sherry, did you have anything that you wanted to say? If not, we can jump straight into our game.
No, thanks so much. So I actually do have experience in IT, and I've been working in IT for many, many years, and it has been an amazing, amazing journey. The reason I came to Perscolas is because I realized that the amount of money that is available, the amount of flexibility, the ability to travel the world has all been able to change not just my life, but the life of my daughter, my granddaughter, and I've even gone back and been able to do some amazing things for my mom. So if you've ever considered an IT career, or whether you haven't, then we'd love to talk with you. You do need to have a high school diploma or a GED. And so we'd love to hear from those of you who are either in the middle of deciding whether you're going to college, or this is a great course to take between high school and college so that you will have not just a regular McDonald's job, nothing wrong with McDonald's, but you can make a lot more money doing IT support on campus to support yourself while you're in school and make a little bit more money than everyone else. So in the meantime, we are going to, if you have additional questions, type them in the chat. Danielle will try to answer them for you. I am going to start a little game here. And so we're going to see how many of you are already ready to be in our cybersecurity class. In the chat, I put a link to a quizzes. You should be able to click that link, and then it will ask you to join a game. I'm going to share the screen so you can see the game. But if you would go ahead and click that link, and it will assign you a name. There we go. Make sure you look at the name that they assigned for you. And as we get people joined in, I will go ahead and share my screen and let us start. It's just a little quick competition. Danielle, if you go ahead and stop sharing, it'll allow me to start. I've only got 5 players so far. And just let us know if you're having any challenges with getting joined on. I'm just going to give you guys a few minutes. And so for those of you who are on, I know if you are already on, or if you're working on getting on, I see we've got about 12 players right now. If you are a school counselor or teacher or administrator, if you would just do me a favor and raise your hand electronically, I just want to get an idea of how many people there are doing that.
I think since this is the Zoom webinar, we might not be able to see them, but if you all wanted to type in the chat, yeah.
Yeah, I see 3. And so how many people are on that are high school students? Just raise your hand. All right, so we're getting started here. I have 12 players. If there's anybody else that wants to play, you can jump on in. If you see the link in the chat, I can share my screen here, and if you want, let's see here. You all should be able to see my cybersecurity screen. If you have a phone in front of your computer and you want to go to joinmyquiz.com and enter the game code 741711, you can do that as well. I'm just going to wait another 60 seconds or so, and then we're going to get this competition started. All right. So here we go. You should see the question come up for you. Make sure you answer on the place where you are. You should be able to see the question. There you go. And it's a short timed question because we're having a competition. Let's see what we got. So far, Chard Moo is in the lead. The question was about cookies, the little small files that websites put on your computer. Okay. What is malware? Got 10 seconds left. Make a good guess. 3 seconds. All right, let's see what we got. Papaya Pan, all right. Good job. Malware is the software that can harm your computer. Now, I see that some people are not getting their answer in. If you are not sure, just guess. Worst case, you can get it wrong. You're not going to be penalized. So let's go to the next question. If you receive an attachment for someone, what should you do? You open it. Someone you don't know. Oh, so Papaya Pan's still in the lead. Allspice is moving up. Hey, everybody got that right who answered. That's awesome. Awesome, 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 awesome. Okay. Let's go to our next question. What type of malware is triggered by the user? Code automatically makes copies of itself. Got a couple seconds left. Click something in. I'm going to give you guys a clue here that as you get more questions right in a row, you get more points. So we're going to do a couple more questions here. You guys having fun? But may result in a malware infection. Okay, Kale is still at the top. Papaya Pan's coming in soon. You can open an email, download a file, or click on an infected link, and all of that could get you malware. These are all questions that the cybersecurity class covers: how you address these things, how you figure out what's going on with someone's computer. This is all a part of the course. What is phishing with a PH? Up. We got Papaya jump back into the front. Okay. Phishing is a scam to get confidential information. You all are rocking this quiz. Most of the people are getting the questions right. That's awesome. What damage can be caused by malware? Oh, look at that. You're staying in the same order. You guys did well. Oh, you guys know the stuff. Look at that. That's awesome. Know this stuff. We already know the things. This is an amazing thing. I'm going to stop our quiz now. We see that Papaya Pan was our winner so far. Do you all have any questions for us?
I know some people were dropping some questions in the question and answer section. I'm going to drop my email inside the chat. If something does come up, you all can please reach out to us, and we'll be more than happy to answer any questions you have.
So we've got some questions. Dr. Adams, we will definitely reach out. Again, this is a cost-free course. And again, you want to be 18, but you can be, our last learner, last year we had a learner that was 61.
Yeah.
So this is a great thing for people of all ages. For our counselors or that have parents that are going through career changes, this is a great opportunity. You're not 18, but you finished getting your high school diploma. We'll have to talk about when you're going to turn 18. But Danielle, did you put in the chat how they can? I did put in the chat earlier our website. It's perscolas.org. If you go to perscolas.org and it'll ask you about getting started now. If you fill out an enrollment form, then we will contact you and talk to you about which classes are coming up and what can be available to you. Fantastic. Well, it has been amazing talking with you all. I appreciate it. Danny, I'm going to let you go from here.
Yes, thank you. Heather, thank you so much for allowing us to have this opportunity to speak with everyone. If you're ever interested in IT or technology, please reach out to us.
Thank you so much, so much, Danielle and Sherry, for being a part of today. I know TAG has been interested in working with you all and placing the students that come out of Perscolas. So thank you for your time today. We are excited that you guys are part of the system and helping us build our talent pipeline for the future. Thank you so much. All right, everybody, this is the end of STEM Day 2022. I'd like to thank all of our presenters today. I hope you've enjoyed it. I'd also like to thank our supporters, BlackRock and Warner Media, who have helped us with STEM Day today as well. If you have any questions moving forward, please feel free to give me a call or email me at heather@tagonline.org. Again, that is heather@tagonline.org. Thank you and have a great day.